Hello, my dear students. Welcome back to the lecture. So sometimes you'll have a footing like this. This is not a rough foundation. It's a kind of a isolated footing only, let us consider. But the shape won't be like the square what we used to get. This was the usual size what we used to get, no? Isolated footing or maybe a combined footing, something like this. But sometimes we get a footing something like this, which doesn't have a proper shape. So in this case, how we are going to do the bar bending schedule? So again, the concept remains the same. There's no much change in that. First, we'll put the bar in the shorter span. Or now you see, again, when I say shorter span, so if I take only this length, it will be shorter. But when I come to here, this will be longer and this will be shorter. So don't have to worry about that. Overall, you try to check which is a shorter one. Okay. So this is shorter for me. I'll go with this one. Okay. Uh, this is my shorter bar. I'll put in this way. Okay. So once I reach here, up to here, I'll put the bar. After that, what will happen? I have to take this complete length. Okay. This I have to count. Finish. And even in this direction also, when I do the BBS, I'll put the bar in this way. Maybe you get some number of bar. Once you're done with that, next this will be only up to this much. Okay. So this is how the BBS has to be done. So first, let me start with that. I'll explain you the simple calculations, how it has to be done. So I'll take the dimensions also. Okay, these dimensions are not clearly visible. No problem. Okay, not an issue. So first what we'll do, whenever you're finding the length, no, you find up to here. First we'll find the cutting length. I'll explain you only for one. First I'll start from here. Up to this portion only I'll do. That's it. And remaining we'll do it separately. So for that what I want this thing. That is this length I want. That is from here to here. But simply I'll note down the length. From here to here, let us consider I'm taking some random value. Okay, I'll consider this to be 5 meter, and let us consider this is 3 meter. Okay, fine. So can you find the cutting length of this? Simple. I'll start my first bar from here. This will be L. Okay, it will go up to here now, and this is 1. Okay, so quickly tell me how you'll find the cutting length, the straight portion bar. 3 meter, I'll write in mm. So 3000 minus 50 from the left side, minus 50 from the right side. Cover I'm deducting, okay? 50 from here, 50 from here. So this will be how much? 2900, isn't it? Yeah. So after that, 2900 plus this L. This L I want, I'll just take some random value, okay? We know how to do. I'll take random value L to be 300 on both the side. So this will come out to be 600. So it will be 3500 mm. Finish. So this cutting length I got. This L bar, this white color bar, I got the cutting length as 3500. I want to find the number of bar. To find the number of bar, I want to take the opposite direction. So you see you have 5 meter now. Okay. But now one thing you need to understand. So in this 5 meter, one cover you leave from here, but you not leave any cover from here. Understand that. This 5 meter, you leave only one cover from here. You'll not leave another cover. So it will be 5000 minus only 50. This time you'll not do another minus 50. Why? Because I'm taking, understand the concept. Because I'm taking the length only up to here. Where I'm taking only up to here. Suppose if I was taking complete length, then I would have done minus 50 from here and minus 50 from here. But now we are doing only up to here. And up to here, the length is 5 meter. So what I'll do, I'll just take this one, 5000 minus 50, which will be 4950. Okay. And divide by the spacing. Let us say the spacing between the two bar is 200 mm. So try to do these calculations and let me know what is the answer you're getting. 5000 minus 50 is 49. Sorry, this is 4900. Okay. Sorry. Yeah. Sorry. 4950. Only 150. No. Yeah. 5000 minus 50. And you divide it by 200. So I'm getting 24.75. I can write this as 25. So now it's up to you whether you want to add +1 or not. Why? If you want to add +1, that is also correct. Make it as 26 number. But when you find the remaining number of bar, that is the next stage. When I find the cutting length in this portion, will not add +1 again here. You are getting my point? No. It is something like the beam case in S1 and S2 portion. Okay, anyhow, beam you don't understand now. Fine. So now if you want to add +1, so I'll add +1 to this 26 number. So this cutting length we have found, number of bar also is found. It's understood. I'll make this as, I'll write this 1. This I'll bifurcate, or this I'll mention it as stage 1. Okay. Now we'll do the stage 2 portion. So if you want, I'll change the color also. We'll go with stage 2. Stage 2 in the sense, this is second shape. So whatever answer I did so far, this is for first one. Okay. Now I'll do for the second one. Now for the second one, again, you want to find the cutting length. Find the cutting length. So again, your bar will start from here. We'll go straight. Fine. Okay. We'll put the bar something like this, isn't it? We'll put the bar like this now. So for this, what all things you require? You want this length. I'll write the length. Randomly, I'll write. Okay. Else you can have a AutoCAD. You can directly measure and you can write. But now just for our understanding, I'm considering this length to be, let us consider it to be 7.5 meter. I'll write 7.5. Okay. This I'll write 7.5. And this width from here to here I want. So this will be, let us say, 3.2 meter. Okay. I'll draw that. So this is 3.2 from here to here, and this is 7.5. And these things I'll bring it here. So this is 2, stage 2. This I'll bring it here. Okay. And this also I'll bring here. Okay. Yeah. And these things will delete. Yeah. Not required. Okay. Understood? Fine. So now again, you tell me how you will find the cutting length of this. It's very simple. This length, it is 7.5, which is 7,500. Minus 50 from both the side, you do it. So it will be 7,400 plus that L on both the side. I'll consider it to be 300 plus 300. Okay. So it will be 7,400 plus 600. So it will be how much? 8,000. 8,000 mm is your cutting length. Understood? Yeah. So this is 8,000. This L, this and this L, I'm considering 300, 300. The straight portion is 7,400. So 300 plus 7,400 plus 300 will be 8,000 mm is a cutting length. Now I want to find the number of bar. To find the number of bar, what I'll do, I'll take the opposite length. This will be my length now. So 3,200 divide by spacing. So spacing, I'll consider spacing as 200. Okay. So now whether 3,200 is correct? No. So 3,200 minus 50 I'll do now. Why? This 3,200 will start from here, I agree. But from here, my last bar will not be placed on this. No, my last bar won't be on this. It won't be like this. My last bar won't come like this. Okay. So you'll be giving a gap of 50 mm. So this is your 50 mm gap. It will go up to here. This will be cutting length. So this gap 50 mm I'm leaving, right? If you're still not able to understand, I'll draw the 50 mm gap also for you. Low. Take. This is that 50 mm gap what we are leaving. 50 mm gap. So that is why what I am doing, 3,200 minus 50 if I do, how much I'll get? 3,150. 3,150. Now 3,150 I'll divide by the spacing. So how much is spacing? I'll consider 200. Now you do the calculation, you divide it by 200. You are getting 15.75, which can be written as 16 numbers. Finish. Again, you don't add +1 to that. Why? Because already +1 I added here. When I was calculating this number of bar, yeah. When I calculated number of bar for this portion, I added +1. Okay. So again, for this, again, I will not add +1. For this already I did +1. For this already +1 I have done. Again, for this I will not add +1. So I only 16. So directly mention 16 number of bar. 16 number of bar required. Okay. Suppose if you had not added 25 plus 1, you had only done 25 in the previous case. So only if it was 25, if you had not added +1 there, then you should add here. So it will be 16 plus 1. See, main intention is you should add anywhere only once. If you, okay, why is that so? Now you may ask, so why is that so? Very simple. If there was a footing something like this, if it was uniform in size, then what you would have done, you would have taken the length and you would have taken this thing, isn't it? You would have taken something like this and only +1 you would have done. No, here also it is the same thing, but our calculation is becoming little tougher. So we took this part one time This part we took another time, but together it is 1 unit only. So that is why +1 either you add in this portion or you add it in this portion. Got it, right? Finish. Your BBS is ready. I did on this side. Similarly, what you can do, you do it on the other side. Other side means this one. So first you finish up to here. This cutting length you can find. Okay, how you'll find the cutting length? 5 meter plus 3.2 is 8.2. 8.2 minus 50 you do. You'll get the straight portion. L you take 300. You'll get the cutting length. Number of bar, how you'll find? Number of bar, this is 3 meter. So from 3 meter, you deduct only 50 mm from here and you divide by the spacing. Let us consider the spacing is 200. So 3 meter minus 50 is 2950. If you want, I'll do it. So 2950 divide by, again, let me consider 200 mm only spacing. So 2950 divided by 200 will be 14.75. So I'll consider 15 and +1 I'll do here. So it will be 16 number. So this is done. After that, you come to the other portion. That is a green color portion. You come here. So this is done. Now next I'll find the cutting length only for this portion. This much one. So how you'll find? This cutting length is very simple. How you'll find this cutting length? How you'll find this cutting length? You know this distance. From here you have to consider now. Now it is bit tricky. What is the tricky part? Tricky part is you want only this length from here to here. But this is not known. You know this is 7.5. So out of 7.5, if I deduct 3 meter, will I not get this length? Obviously, I'll get. So do that. 7.5 minus 3 will be how much? 4, no? 4 meter. No, sorry. Yeah, 4.5, 5.5, 6.5, 7.5. This will be 4.5 meter. What happened? Okay. Yeah. So this is 4.5. I'll write here. This is 4.5. Fine. So you have this 4.5 meter. This is 3 meter. Can you not find the cutting length of this? So this is how much? 3.2, no? So mention it. So 3.2 or 3200 minus 50 on both the side will be 3100. And then 3100, this L 300, this L 300 I'll add. So it will be 3700 mm is my cutting length. Okay, finish. How will find the number of bar? So number of bar will be, how you'll find the number of bar? This is 4.5. So in the 4.5, only 50 mm cover you deduct from here. Here no cover will be deducted because it's already taken. So it will be 4.5, no? So 4500 minus 50 will be 3450, isn't it? Yeah, 3450. You divide it by the spacing. I'll consider 200 only spacing, okay? For our easiness. Else in the drawing, it will be mentioned. So I'm getting 17.25. 17.25 can be taken it as 18 number. But should I add +1? No, because +1 was already added here. When I was finding this green color, I already added +1. So again, in this portion, will not add +1. So 18 number of bar is required. Finish. You have a number of bar. You got the cutting length of this. You multiply the weight of the 10 of how much? Let us consider I'm using a 16 diameter. I'm using a 10 diameter bar, which is 0.62. You multiply, you'll get the weight of the green color, white color also you have found, green color you have found. So in this way, you're supposed to do the BBS if you get a drawing something like this. Got it? So I hope you have enjoyed my lecture up to here. You got an idea like how the BBS has to be done if you get a footing which is not rectangle or square in shape, which is something unequal, irregular shape. So I've explained you this. So try to understand it. Maybe in future when you work on real projects, you may get a footing something like this, or you may even get a footing something like this. Okay, whose shape will be something like this. Sometimes those things happen due to the site conditions and all. You may not get a exact 90-degree footing. You'll get a footing something like this. Can you do the BBS for this? Obviously you can do now. Okay, sometimes you may get a footing something like this. Then it will be like this. Here it will be like this. Okay, same thing, but here now this shape has changed. That's it. You can do the BBS for this. You can do this also. You can do what you'll do. First, you finish this portion. First, you find the BBS for this portion. Okay. Once this is found, then you found the BBS for this portion. Similarly, you do the same thing on the opposite direction. That means you find this portion first. After that, if you want to find the longer span, this you finish first. Once this is done, next you come for this portion. Got it? Same thing here also. First, you can go anyway. Shorter span will be this one now. So first you do for this side. Once this is done, okay, you come to this portion next. this much BBS you do shorter span. So once your shorter is done, for the longer again you start from here. For longer you start this portion first. So once this is done, the remaining portion, that is this one, you do it later. Got it? That's it. So I hope you have enjoyed my lecture up to here. So in this way, almost all the types of footing we have covered, and we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So once we have done with the footing bar bending schedule, the next is that we are supposed to take care of the column bar bending schedule, right? Now again, what you're supposed to do, whatever you have to create a new sheet, okay? Create a new sheet, something like this. And whatever you had written at the top, no, like this project, the serial number, everything you have to copy and say Control C and come to the next sheet, okay? And say Control V. Got it? So everything will get pasted, and similarly try to drag few of the things, okay? And here few things are not required, we'll delete all those things. For example, this column and this column, since we had used it for the BBS of the footing, that is not required. You select that two column and say hide. So it will get hide, it will get hided, okay? And then you can drag it in this way. Then again, after that, rest all things let it be there. In this again, we are supposed to delete one or two column, which is not required. Rest all things look similar. Okay, you just drag it. It's good. Now here, type of the element will be column now. So you make the changes as, make it as column. Okay, good. Then lap length will be there, development length. This you can make 50 and this you can make 50. Okay, both will keep. And this is total steel quantity in column. Okay, these are the few changes which you are supposed to do now. Other than that, concrete cover, it will be 40 mm. For footing, it is 50. For column, it is 40 mm. Okay. Grade of concrete is same, and rest all things are okay. Now, along with this, what changes you are supposed to do? We'll start that. Okay. Let me go back to the drawing. Number of bar, dia of the bar, let the spacing, number of bar, yeah, let everything be there, not an issue. This spacing is not required for the column main bar, but for the stirrups we require, and for the lateral ties it is required. So let this be there. Okay, finish. So everything is correct. You just give a thick box, fine. That's it. Now, before we start with the column reinforcement, column BBS, we need to understand certain basics. And once we understand that, once we do it manually, then we'll go with the Excel sheet. Okay, up to here you correct and keep it. Now first we'll go with the drawing. Okay, now see, for the drawing, what you're supposed to do, this is a drawing by the name residential building BBS. This is what I've uploaded. You have to download the same drawing, and this drawing you're supposed to follow. The reason is that there are few changes what I've done, so that is why you have to follow this drawing. In the initial day, I mean in the quantity estimation, I had given you one drawing. There also the schedule of column is there, but don't consider that drawing. This drawing you're supposed to consider. Okay, because the BBS is made according to this drawing. Later I'll take you that drawing and I'll explain you that also, because that is a bit complicated. So since we are learning it for the first time, I don't want you to get complicated. So that is why we'll go with this drawing. This is, I made certain changes in this, follow this. So the name of the drawing will be residential building BBS. Okay, this drawing only I've uploaded, you can download and use it, fine. Now here what has happened, all the columns they have given, right? What is the size of the column? 200 by 300, 200 by 300 is the size of the column. And in column usually we have two types of bar. Okay, one is called as longitudinal bar, that is this particular bar, which will go straight in this way, okay, which will have a L shape. This is called as longitudinal bar, or we call it as a main reinforcement. And then we'll be providing the lateral ties. It is actually a lateral ties, few people call it as stirrup, which is not right. We call it as lateral ties in case of the column. Okay, this much is understood. If you're not clear here, I'll show you one or two images so that you understand. Yeah, for example, this is called as longitudinal rebar, the one which is going vertical. Okay, it's called as longitudinal or main reinforcement. And then the one which they have provided here, this one, okay, the ring, a kind of a ring, you can see this ring, this ring, this is called as lateral ties. This two we are supposed to find. Okay, so that is why whenever you look into the drawing, you get it something like this. The size of the column is done, it's written main reinforcement, that is the vertical bar. You're supposed to make use of 12 diameter bar. How many number? 6 number. To put it in a better way, like it is like this. So there will be 1, 2, 3, 4, 5, 6 longitudinal bar will be there. Okay, that is what you mean by that particular statement, this thing. Okay, and stirrup, this should be lateral ties. This people have written stirrup, it's okay. It's written you're supposed to make use of a 8 mm bar for making a lateral ties. and the spacing between them should be 200 center to center spacing. So that means, again, if I go back to the drawing, go back to this practical image. So this is your lateral ties. Okay, this is your lateral ties. This is lateral ties 1. Okay, in this way, this is your second lateral ties, and the spacing between this lateral ties, from this lateral tie to this, it has to be a 200 center to center spacing. This much is understood. 200, 200, 200, 200, 200, and this rebar is should be made use of a, this ring should be made from a 8 bar. Okay, this much is clear, no? Fine. That's it. Now they have given all these things, like how that ring should be. You have two rings. One is called as master ring, which will be something like this. Okay, the same thing what we can see here. This is that master ring. Okay, this one which has gone completely, no, this circular, I mean this one rectangle, it is completely gone, no? That is master ring. Along with that, in few of the structural drawing, based on the requirement, we have given one more link. This is called as a link. We have seen all these things. I hope you know what is this link and all, because it is taught in my basic drawing reading course and in my site engineer course and all. Okay, I think again there's no point in explaining that same thing. Okay, it is already explained. Okay, so because I don't have even image for that now. If you don't have much knowledge, you just message me, I'll explain you that. But again, I'm thinking that since it's an advanced course, I'm thinking that you know all these things. Again, I'll not go and show you each and everything. Okay, done. Fine. If you still have doubts, you can get back to me. Okay, not a problem. Okay, this much is understood. Chalo. Fine. Then again, now one thing we need to understand, whatever they have shown, no, it is from footing to the ground level. That means your column, for example. Okay, so how do I explain this? Yeah, we'll see. Now, your time will go here just to understand few things, and once we understand, we'll go with the BBS. Okay, so directly I cannot take you to the BBS part, since we need to understand few things from the drawing, and column BBS will take little time to understand and also to do it. Yeah, so this is a column reinforcement. Okay, so this is a column reinforcement. Your reinforcement will start like this. It will be over the footing, like, wait, it will start like this. Okay, your bar will go, and your bar will go straight in this way. Okay, up to the whatever floor. If you have 5 floor, it will go up to the 5 floor, but not one single bar will go 5 floor. For that, you have to do lapping, and you have to cut the bar and all. Okay, getting my point? And here, that is why these people have written, like, see, this is up to the plinth level, this is to the top of the plinth beam, and from the plinth beam to this is your first floor. From first floor, this is your terrace, and from terrace, it is above the terrace. So let us say, I'll remove all these things. Okay, this is not required. I'll do it in this way. Okay, so let us say, this is my first floor. I'll write this as first floor. This is my first floor. This is my second floor, and this is my third floor. Okay, you're getting my point? So your bar will start from here. It will go, this is the top of your plinth beam. Okay, from there to here, this is your first floor. This much part is your second floor. This is your third floor. Got it? So how that bar has to go, that is mentioned here. Where it has been mentioned, it's written in this way. See, from the footing to the ground level, this is the reinforcement you're supposed to use. Okay, and from ground floor to the first floor, again, you're supposed to use of 12 diameter 6 bar. Okay, and then your lateral ties will be so and so, and in that way. Then again, from first floor to the roof level, you have to follow this particular drawing. Okay, and then roof level to the top of the roof level, it has to be followed in this way. You're getting my point? Okay, now why these things has to be given? Because if you're constructing a G+3 G+4 building, it's not that only one bar, whatever you take from the foundation, it will go to the top. That usually, that, I mean, if it is a G+3 building, usually that happens. But when you're going for a very high rise building like a G+5 G+6, in that case, that is not the thing. There, what we try to do, we'll take a ground floor beam, for example. We'll take a bar from here. Let us consider it's a very high rise building. Okay, so from here, we'll take a, let us say, a 12 diameter bar. So this 12 diameter bar will go up to first floor. Let us consider. Fine. After that, from first floor to the, let us say, up to fifth floor, 12 diameter bar won't go. Let us say it will be a 16 diameter bar, or let me put it in other way. Let us say from here, a 20 diameter bar is going up to the, let us say, first floor. Okay, and from first floor onwards up to the fifth floor, 16 diameter bar will go, because there the requirement will be less. So in that case, what we do, I'll go with the 16 diameter bar. So this is my 16 diameter. I'll give a lap here. Okay. And my bar will be, I'll take in this way. Got it? So that is why when you write, that is why in the drawing it will be mentioned. This 20 diameter bar will be only up to the ground, up to the first floor. From the first floor to the fifth floor, it will be a 16 diameter bar. Okay. So that is why in the drawing it will be mentioned like ground floor to first floor, what you have to follow. Okay. From footing to ground level, 20 diameter 6 bar. Okay. Then again, ground level to first level, again it is a 12 diameter 6 bar. Okay. Then again, from first floor to roof level, it is a 12 diameter 6 bar. Again, roof level to top of the roof, it is 12 diameter 6 bar. That means right from foundation up to the top of the roof, everywhere you are supposed to make use of a 12 diameter, which is 6 in number. So that is why this drawing I modified, because if you had taken my original drawing, there is a variation. So that variation I'll take it later, not now. Now we'll assume that whatever reinforcement we are getting in all the column from C1, C2, C3, diameter may be different, but the number of bar will be from the foundation to the top up to the G+2 building, everything it is same. This much is clear. This you have to fix in your mind and refer this particular drawing. This much is understood? Fine. So next we'll start with the BBS of my footing. Okay. So we'll start with the bar bending schedule of the footing. So how do you identify? How do you do the BBS? So for that, if you remember, in my quantity estimation course, we had done this bifurcation. We had done this this thing. What is that? Classification. That means we had separated the column based on the footing. Like my C1 column is coming on F1 footing. You remember, right? My C8, C12, C25 column is coming on F2 footing. My C9, 10, 11, and 20 column is coming on F3 footing. Now again, I don't explain this because you know C15, 21, 22 is coming on F5 footing. C27, C17, C23, F is coming on F7 footing. Got it, no? How did we classify it? We took the footing, and on F1 footing, how many columns are coming? We have classified that. Then we took F2 footing. On F2 footing, whatever columns are coming, we have classified. How did we do that? Very simple. If I go back to that, this was the footing what we had, isn't it? This was the footing we had. We search for F1 footing. So where is my F1 footing? So my F1 footing is somewhere here. Yeah, F1 footing. So on this F1 footing, which column is coming? C1 column is coming. 1. Is there any other F1 footing now? So there is no other F1 footing, right? I think there is no other F1 footing. Finish. That's what we wrote, like this column, that is C1 column on F1 footing. The same thing you can see here. C1 column on F1 footing. Got it? Next, I'll go with the second one. Okay, I'll take one more just to clear out doubt. Now look for F2 footing. So where is my F2 footing? So there is one F2 footing here. Fine. On this F2 footing, which column is coming? C8 column is coming. Good. Is there any other F2 footing? Yeah, I have another F2 footing here. But which column is coming? C12. That means on F2 footing, I have a C8 column also. On F2 footing, I have C12 column also. And then again, where is my F2 footing? Another F2 footing is here, right? F2 footing, which column? 25. That means C25. Remember the column name. C25, C12, and C8 columns are coming on F2 footing. That is why I wrote here C8, C12, C25 column on F2 footing. The same thing, whatever we wrote there, based on that only we'll do the bar bending schedule. Now you'll ask me one question. So why it has to be done in this way? Because the height of your column reinforcement, whatever you're putting, it depends on the footing which it is coming. That is why this becomes very important for us. Otherwise, if you don't want to follow this, you can come and do individually. You can take you can take each one of this. You write first C27 column F7 footing. You do a BBS for this. No problem. You take C28 column on F8 footing. You do the BBS for this. You take C25 column on F2 footing. You do a BBS. You will get the right answer. But what will happen? The calculation will be very lengthy. So instead of that, once we group, it will be easy for us. Why? Because the moment you group and you go to the Excel, you prepare this Excel sheets, you just have to input here like we have done here. Okay. Like see, C8, C12, C25. 3 columns on F2 footing I told. So that is why I written number of member is 3. Then directly I'll get the answer. Otherwise, what you should have done, C8 column on F2 footing. You do this calculation. Then again you go for which one? C12 column on F2 footing. Again, you do another calculation. Then again, you go for C25 on F2 footing. Again, you do the calculation. So 3 times it will be lengthy calculation. Instead of that, we have grouped that and 1, 2, 3 columns. So directly I've written 3. My answer has changed. Suppose there were 4 columns. If the moment I do 4 here, your answer will change. Getting? So that is why this classification has to be done. Clear? Two things we have cleared now. No more doubts left. Now we'll start with to find the cutting length of the bar. Okay, fine. So find the cutting length of the bar. First, the main reinforcement I'll teach you how it has to be done. So before that, you should understand how the bars are practically placed. Okay, so you know that, but still I'll quickly give you an idea regarding that, how the bars are practically placed. Okay, so just that L shape I need to identify, and then we'll start with that. Yeah, so whenever you place the reinforcement, this is column reinforcement. So your column rebar will come from the top and it will be given a L shape here. This is the L shape. So whenever I find a cutting length, I want to find this length plus I want to find the height of that. If I add both, I'll get the total cutting length of the bar. If I find one cutting length of one bar, and if I multiply this by number of bar, like this is 119. So if I multiply like 1, we have 2, 3, 4, 5, and let us say 5 on the other side. If I multiply this by 10, if I get 10 bar, so 10 into cutting length of one bar will give me the cutting length of all of my bar. Very simple. Chalo. Good. So this much is understood. Now we'll start with the real calculation of this. Okay. Yeah. So first what we'll do, go back to this Excel sheet. What I've written, C1 column on F1 footing. So in my BBS also I've written the same thing. Okay. First what I'll do, no, I'll directly teach you here. Then I'll teach you how to prepare the Excel sheet. First you understand the concept. Okay. Now here in this particular video, I'll teach you how to calculate the cutting length. And in next video, I'll teach you from the scratch how to prepare the Excel sheet, something like this. Okay, fine. So I've written here C1 column on F1 footing. And what is the size of my column? It is 200 by 350, which is given in the drawing. C1 column, they have given the dimension here. You have to pick from here. Okay. So my C1 column, where it is C1 column. So yeah, C1 column is here. See, C1 column is here. And for the C1 column, what is the size? It is 200 by 350. Same thing, I've written it here. Okay. I've written here 200 by 350. Now it is resting on which footing? F1 footing. So what I did, I wrote F1 footing. I wrote the size of F1 footing also. That is 1200 by 1200 by 400 mm is the depth of my footing. So in that, what I've done, this 400 I've written, it's the depth of the footing, because this depth itself is required for us to find the height of the bar. Okay, you write 400. Why did I write 400? Because my F1 footing depth is 400, that we got from the drawing. Now we need one more thing. In the F1 footing, what is the diameter of the bar? See, column we are finding, but we want the reference of footing also. So that is why I come to F1 footing. The depth was 400. It was 1200 by 1200. This reinforcement I require, that is L1 and B1. That is diameter along the shorter span and diameter along the longer span. So I'm using a 10 diameter bar in the bottom and also along the shorter, and 10 diameter along the longer. So 10 and 10, no? So that is why what I've done, I've given an input here of saying that this is 10 diameter. Anything is okay. You take this as shorter, you take this as longer. Doesn't matter, because we want this diameter. Got it? Fine. So now what we'll do, we'll start with this. Yeah. Yeah. So first we'll start with this. So first what you're supposed to find, this particular thing, this L shape I want to find. Okay. I'll go with this only. Yeah. First, see, I'll tell you what has to be done. So this is my footing. Okay. This is my footing. First, I just want to find, this is my footing. Okay. Your bar will come like this. Your bar will start from here. Your footing bar will, your column bar will start like this, and it will go on like this. Okay. We are not concerned with that. Right now, I'm concerned with only this particular length. Which is that length? This particular length I require. That is from the top of this column, top of the footing. This is your top of the footing. From this here to this length I require. Getting my point? This much length I require. Okay. If you want, I'll show it in this way. This particular length only I require, up to here. This length I require. How do I find that? So this length is nothing but it is actually a development length. If you remember, this length is nothing but it's actually a development length. Okay. So usually if you see the drawing and all, they mention like this is LD. Okay. From here to here, it is a development length. That is what they mention. And usually they mention that it has to be 50 times the diameter of the bar. What they mention? 50 times the diameter of the bar. Usually, most of the cases, they mention it in this way and write 50 into D. It's a development length. Okay. Here they haven't done, but most of the drawing they do. Suppose if I take you a few drawing, if I go back to this drawing, let me see. Yeah. See, exactly. This is what I wanted. See, from here, this is your footing, okay? From the top, I'm just finding this length. Don't observe anywhere. Whatever I teach, you listen that. This length, I want to find now. Where from here to here. This length I want to find. This length I want to find. Okay, great. So how do you find this length? This length they directly they mention. See, LDT. This is development length in tension. Okay, but usually this entire thing is the development length, and they mention that it will be 50 times the diameter of the web, 50 into D. Okay, this much we got. This is entirely 50 into D. But when I do the calculation, I'll find it separately. This entire thing is 50 into D. Okay, but I want to find this height. How do I find this height? It's very simple. I want only this height. Okay, this entire thing is 50 into D. I'll do it. Let us consider I have a 12 diameter bar. Tell me what will be 50 into D? 50 into 12. It will be 600 mm, right? Simple. If I'm considering a 12 diameter bar here, what is the development length? It will be 50 into D. So 50 into 12 will be 600 mm. 600 mm? Yeah. 12 5 is 60. Yeah, 600 mm. Okay. So this is overall is 600. But now I want to say only from this vertical height how much it is, that I don't know. How do you find that? It's very simple. You know the depth of the footing. You know this depth. From here to here, you know the depth. From this depth, you know this overall depth. Okay. From this depth, if I remove the bottom cover, footing cover, if I remove, that will be 50 mm. And if I deduct this rebar and this distribution rebar, will I not get this particular height? I'll do it in this way. Okay. See, I want to find this height now. This height from where? From here to here. This height I require. How do I find this height? Very simple. Whatever is the depth of the footing, whatever is the depth of the footing, from there, if I deduct this, okay, I'll do it in this way. From whatever is the depth of the footing. From there, if I remove this cover, this will be cover, which is 50 mm. And in that cover, again, if I deduct this red color rebar, bottom rebar, and if I deduct this distribution steel, will I not get the height of this rebar? From here to here, obviously I'll get, because why I'm deducting this top distribution also? The reason is this L shape, this L bar is sitting on this bar. So if you're not able to understand this thing, I'll quickly show here. See here. This L, where it is sitting? This bar which is coming, no? It is sitting on which bar? It is sitting on 2 bar. That is, see, horizontally there is 1 bar passing and vertically there is 1 bar passing. Over that, this L is sitting. That is why overall depth minus bottom cover. This is cover, okay? 50 mm cover minus this horizontal bar and minus this, this shorter span bar and longer span bar. If I deduct, I'll get the straight length of my bar. Pretty simple. Same thing, I have done it in the Excel sheet now. Okay. So what I did, first I'll tell you how it has to be done. So how did I get, yeah. Yeah. Okay. So first I'll find this particular height. Just now, whatever I calculate, that I'll find. Okay. So what I did, I'll do it here again. 330 I'll bring. Plus bracket open. What is the depth of your footing? That is why I written depth here, 400. Now we're getting the importance. That is why I wrote F1 footing depth here, 400. Minus, exactly, 50 mm is your footing cover. Minus, I want the shorter span diameter. I want the longer span diameter. That is why I had written 10 and 10. So minus this one and minus this one and close the bracket. Enter. How much I got? 330. So 330 is my vertical distance. Okay. Now, if I get the vertical distance 300, and I know that from here to here, from here to here, it is development length, which is 50 times the diameter of the bar. Okay. So out of this 50 times diameter of the bar, already my 330 length is calculated. If I, from 50 times the diameter of the bar, if I deduct this 330, will I not get this particular length? Obviously, I'm going to get. So next what I'll do, I'll calculate that. So that means, I'll do it here. Okay. Yeah. So plus open bracket, development length is 50 times the diameter of the bar. So 50 is already written here, 50. I'll multiply this by diameter. Diameter of which one? 50 into diameter of the bar. Okay. Yeah. Yeah. Okay. Plus 50 is here development length, multiply by column I'm doing. So column diameter I have to take 12. Okay. Getting my point now? So fine. 15 to diameter of the bar minus this length, straight length, and close the bracket. Enter. How much I got? 270. Finish. Pretty simple. So this is 270 and this is 330. And if I add 330 plus 270, that will be equal to the development length. If you want, I'll verify that also. What is your development length? 50 into this one, no? 12 diameter. It has to be 600. 600. Okay, see, you may find it a bit confusing initially, but it's very simple. Yeah, it's very simple. 600. And if I add 270 plus 330, it has to be 600. So that also I'll do here. Plus 330 plus 270. Sorry. Plus 2. Okay. Finish. It has to be 6. Matching, no? Finish. Very simple. That's it. You understood this concept. I'll quickly repeat it. I know the development length. This is LDC. Okay, I'll quickly draw it here. Okay, for someone who has not understood, I'll repeat it. For someone who has understood, you can skip this part. Okay, we know that this is a development length. What is given? It is usually 50 times the diameter of the bar. 50 usually. Sometimes if it is not 50, sometimes they may say it is 60. In that case, you can write 60. Okay, 50 into diameter of the bar. This is my overall development length. But I want to find only this particular height. If I want to find this particular height, whatever is the depth of my footing, from there, if I deduct the bottom cover, which is 50 mm, minus if I do the shorter span diameter and longer span diameter, I'll get this height. So that is how I got 330. What I did, overall depth minus 50 mm cover minus shorter span diameter minus longer span diameter. I got this height. Finish. The moment I get this height, finding this L, finding this is very simple. How? Why? Because overall development length is 50 into D. In that, if I minus this 330, I'll get this horizontal. That is what I did here. So what I did, this development length, that is 50 into D. And when you take diameter, you should take the diameter of the column, not the rebar diameter. It's the diameter of the column, 50 into D. Okay. Minus this height, if I do, I'll get this horizontal length. So that's how I got. Pretty simple. After this, your calculation is very simple. So I found this vertical length. I found this horizontal length. Next, what I want to find? Next, I want to find the total height. That means, what do I mean by total height? That means right now, yeah. So right now, whatever calculation I have done, that is only up to here. Where from where this length I got, this length I found, and I found this length. That is only up to here I have found. But now again, I want to find from the top of the footing, from the footing, top of the footing up to the top. Wait, let me do that. Okay, this you can imagine, no? This is different. Yeah. So far I found this length I found, and I found up to here. Okay. Now my calculation is to be from this top of the footing to this complete height I'm supposed to find. This height I'm supposed to find. How I will do that, I'll teach you now how it has to be done. Okay. Yeah. So for that, few things I'll explain you anyhow. We'll start with this only. Yeah. Yeah. One thing I'll teach you here only. First time I'm teaching you here. I mean, first time you people are listening to me. So small confusion, those things will happen, but it's very simple. Okay. Fine. Next, what I'll do. Next, what I'll do. I want to find this height now. Next, I'll break it down. Now, this is a plinth beam top. Next, what I'll do, and this is plinth beam bottom. From the plinth beam bottom, that means plinth beam bottom is this is your ground level. Okay. This is my GL level, ground level, from where you started the excavation. This is my ground level. Now, what I'll do, I'll start to find this particular height. If I get this height, rest my calculation is very simple. I want to find this particular height now. Okay. How do I find this particular height? It's very simple. It's very simple. Initially, if you look into the drawing, this height was actually given for us. From the ground level to the top of the PCC or bottom of the PCC, they are told that you have to do some 2 meter of excavation. 2 meter of excavation. Okay. So this 2 meter is given to us. That means this height is given to us. From this height, if I deduct this footing depth from the overall depth of the excavation, if I deduct the footing depth, what is left out? Will I not get this particular height? I'll repeat it once again. See, this is my depth of the footing. Okay, from the ground level I'm standing. From there, it was mentioned that you have to do the excavation till the bottom of the PCC, or let us say top of the PCC. It was 2 meter. It was 2 meter excavation. But I want to find only this height. From that excavation depth, if I deduct the depth of the footing, will I not get this particular distance? Obviously, I'm going to get this particular distance. Will I not get? Obviously, I'll get. That is what I'm looking for. Now I'll go back to the drawing. We'll do the same calculation. Okay. Okay. So in the Excel sheet also we have done the same thing, but I'll teach you here how it has to be done. So I'll go back to the drawing. Yeah. So now what my concern is to find this length. Okay. My concern is to find this length. For the same drawing I'm teaching you, I want to find this height from this to this. Okay. I want to find this height now. How will I find? Very simple. It's very simple. How do I find? Already see from this level, natural ground level to the top of the PCC. It is given you have to do a 2500 mm excavation. From this, if I deduct the thickness of my footing, if I deduct this particular thickness, will I not get this particular height? Obviously, I'll get simple calculation. So we know what is the depth of the footing, where it is mentioned. We are taking F1 footing. This is F1 footing, and the depth was 400 mm. Now just apply the calculation here. 2400 minus 400. If I do, it will be 2100. So this is 2100. Simple. The same thing has been done in the Excel sheet also. Okay. So what I have written here, see, 2500 minus D12. D12 means I've taken this one. This is D12. Got it? You're getting my point? Forget about other things. Leave. And yeah, I'll do a separate thing for you. Okay. So plus, open the bracket. What I'll do now, I'll say depth of excavation is 2.5 or 2500. I'll write 2500 minus how much? Depth of footing is how much? 400. Finish. It is 2100. So this particular height is 2100. Now where did we reach? That is important. By doing this calculation, where did we reach? We reached till the bottom of the plinth beam. We reach up to the bottom of the plinth beam or natural ground level. Now from here onwards, our calculation is very simple. I'll take you to this drawing. Right now, where did we reach? We reached to this particular point. Okay. See, it's very simple. If you're getting confused, just wait for 1 or 2 lecture. After that, you will master this. Okay. It's very simple. Now, we did everything. Okay. We found this horizontal length, right? Agree with me? And we found this vertical length up to here, up to the bottom of the plinth beam. Now, after this, what we are supposed to do? After this, I want to find this particular height from here, from the bottom of the plinth beam to the top of this, I want to find. It's very simple now. What all things you can observe? We were here. If I add the depth of the plinth beam, and if I take all the floor, this is the ground floor, this is first floor, and this is my second floor. Okay, this is my first floor, this is my second floor, and this is my roof. And if I write the floor to floor height is 3 meter, floor to floor height is 3 meter, floor to floor height is 3 meter, and this plinth beam depth is 450 mm. 450, I'll write it as 0.45 meter. If I add all these things, will I not get the complete height of this bar? Very simple. We reached up to here. I'll add 0.45 to that. So I'll reach to the top of the plinth beam. And now from the top of the plinth beam, that means you're actually in the ground level. From ground level to the first floor top, your height is 3 meter. From first floor to the second floor, your height is 3 meter. From second floor to the terrace, your height is 3 meter. If I add 3 meter, 3 meter, 3 meter, plus if I add 0.45, and if I add all these things with the previous answer, will I not get the complete height of my bar? Obviously, I'll get same thing I'm supposed to do now, right? I'll do the same thing in the Excel sheet. So what I did now, up to here I reach. So now, yeah, up to here I reach. Up to this point, I'll put a bracket here. Okay, close the bracket. I mean, open the bracket, close the bracket. Okay, plus what is the depth of your plinth beam? For that, what you have to do, you have to go back to the drawing. See, few things you have to go back to the drawing. And in this drawing, our plinth beam was actually 350 mm, if I'm not wrong. In the quantity estimation, you have seen that. Okay, for that, I'll come here. This is my plinth beam. And if you see plinth beam, depth of the plinth beam was 350 everywhere. So I'll take 350. Okay, how did I get 350? All these things will be given in the drawing. If you had followed my quantity estimation, there we had taken the depth as 350. So what I'll do, I'll take 350. I'll go back here. Okay, so I'll write 350 mm. Finish. Now where did we reach? Tell me, where did we reach? We reached till the top of the plinth beam. So top of the plinth beam is ground level. From ground level to the first floor, what is the floor to floor height? Where it is written? Again, you have to go back to the drawing, come to the drawing, So if you take this section, this is my section what I had, isn't it? So if you remember, this was the drawing what we had. And what was mentioned here, this is your ground level. You can see from the ground level to the first floor, what is the height given? 3.3 meter. From first floor to the roof floor, what is the height given? 3.3 meter. From the roof to the top of the roof, what is the height given? 3.3. That means my floor to floor height is 3.3. How many floor is there? We are looking into a G plus 2 building. Ground floor, first floor, second floor. That means it's a G plus 2, no? From ground floor to one floor is 1. From first floor to second floor is 2. And from second floor to the roof, it is 3. That means 3 times I need to add 3.3, 3.3, 3.3. Only then I'll reach to the top of this. Okay, getting my point? If it is G plus 2, that means 3 floors will come. G plus 1, 1 floor, plus 1 to plus 2 another, then another roof will come. Okay, fine. So that is why what I'll do, plus 3,300 one time. This from here I'll reach to the first floor. From first floor to second floor I'll reach 3,300, and from there a roof will be there. Okay, 3,300. Finish. Everything is done. Hit the enter button. How much I got? 12, 12350 I got, right? But here I got 14110. What is the reason? The reason is that two things we didn't add. The bar which will go to the top, this bar, where is that? This bar, the bar which will go to the top. From here you started your bar, no? It will go to the top, but it won't go to the complete height. I mean, it won't touch here. We'll leave a gap of, we'll give a gap of 40 mm. That is called as column cover. So it won't go completely here. We'll leave 40 mm and you will stop the bar here, right? In the footing, what we were doing, 50 mm cover we were leaving on the sides and even on all the four sides and even the bottom and the top. Same thing in the column also. We are supposed to do that. Okay. Same thing in the column also. We are supposed to leave a gap of 40. Gap means a cover of 40 mm. Okay, so that is why what we'll do, we'll come back to the Excel sheet and we'll write minus 40 now, minus 40, and I'll hit the enter button. Is it the answer matching here? No, still the answer is not matching. Why? Because for a very same reason, what is the total height we are getting? 12,12310. That means 12.31 12.310 meter. We already written the height of one bar, the height of rebar length, what we are written, 12 meter. Okay, after 12 meter, you have to join one more rebar. So that means there's something called as lap. You have to add the lap length also. You have to add the, I mean, you have to deduct the, yeah, you have to deduct, you have to add the lap length also. Okay, you're supposed to add the lap length. So again, I'll go back to the drawing. See here. So what will happen, this lap length, I'll teach you. So you'll start your bar from here. Okay, you'll start your bar from here. It's a 12-meter bar which you're going to start, and it will go up to here. Okay, it will go up to here. Finish. After that, you will add one more bar. This is your next bar. What you'll do in the next bar, you'll do the lapping. Lapping means you will bend the bar here. It will lap here. It will go to the next floor. Finish. This bar will stop here. Then you'll bring one more bar. Okay. Again, this bar will come from here. You'll give a small crank and it will take into the top. Okay, finish. You're getting my point. Then again, it will, another bar you're going to bring. You'll bring another bar. Okay, bring another bar. You give a crank. Okay, like this, and you'll take it to the top. So this is called as lapping. So whatever this lap length is happening, no, that will be mentioned in the drawing. But here I have considered 50 times the diameter of the bar. My lap length and development in both are 50 times the diameter of the bar. Sometimes in the drawing they mention you have to take a lap length of 47 times the diameter of the bar. In that case, you take 47 diameter. For a few times they mention 60 into diameter of the bar. You take 60. But here I'm assuming, not assuming, usually we go with 50 into D. So I'm taking 50 into D. Okay, very simple. So how many lap length will come? See, now you may ask me one question. Sir, total height is this much. One straight bar, 12-meter bar, we never give because your rebar will fall later. So what we do, the usual practice, what we do is every floor we give one lapping. What we do? Every floor we give one lapping. Simple. So once your bar start from the foundation up to the center of the plinth beam, you give one lapping. Again, you ask me, so why it has to be given in the center only? For the very same reason, in the center, the bending moment will be minimum. If I ask you to draw the bending moment diagram of a column, if this is my column, this is my column, and when the load comes on this, how the bending moment will happen? If the load comes on this, how the bending moment will happen? So the bending moment of this will be something like this. Okay. So if this is my column, if I ask you to plot the bending moment, your bending moment will be like this. So here it will be maximum bending. Here also the bending will be maximum. Okay, bending will be maximum, and it will be joined in this way. So this center portion, whatever you have, no. So this center portion, whatever you have, no, here your bending moment will be minimum. So wherever the bending moment is minimum, there only we have to do lapping. Why? Because whenever you do the lapping, this becomes a weak joint. So there is every chance from here your rebar may come out. Okay, come out. So whenever we we lap in such a zone where the bending moment is minimum. So that is why at the center we do. That is why you can see everywhere. No, I've taken it to the center. This is center. If this is floor to floor height, center of that I've done the lapping. If this and this is floor to floor height, center I've done the lapping. Getting my point? Okay, that's it. So what you do, you don't have to do in that way. Just remember every floor I'll do one lapping. Now from here to the top of the plinth, middle of the plinth, this is one floor, one lapping I'll do. From the plinth to the first floor, I'll do another lapping two. From here to the top, I'll do another lapping. So total how many lapping will come? Three lappings will come. Three lapping. So I just have to multiply three lapping three into what is the lapping length? It is 50 times the diameter of the bar. So 3 into 50 into diameter of the bar. If I do, I'll get the total height of that. Pretty simple. That's it. So I'll go back to this. I'll go back to this. Yeah. So what I'll do, I'll have to add that. No. Yeah. So what I'll do, come here. Yeah. So this I'll say plus. Oh, it won't be minus. It is plus because we are adding the bar here. It won't be minus. It will be plus. Plus how many times? Three times. Because from plinth to foundation to plinth, one lapping will come. From plinth to first floor, another lapping will come. From first floor to second floor, another lapping will come. So total three lapping will come. So 3 into what I'll do? Sorry, 3 into 50 times the diameter of the bar. So 50 already it's written here. Lap length 50 multiply by diameter of the bar. Column diameter, how much it is? I've written 12 here and close the bracket. Hit the enter button. Finish. How much it's coming? 14110. Same answer I got here. That's it. This is how you are supposed to find the cutting length of the column rebar. I explained you for this. In the future lectures, we'll do all this calculation. This calculation is very simple. You're done footing. You got the total cutting length. You add this one. You add this part. You add this part. You add this part. You'll find the total cutting length of one bar. Then you have to find how many bars are there. For that, it is directly given in the drawing. It's not like footing. Directly they will mention in the drawing. Like here, if I come, it is mentioned that your C1 column. This is my C1 column, no? C1 column. It is 200 by 350 size, 16 diameter, 8 number. Finish 8 number. I found for 1. So I'll multiply this by 8. I'll get the cutting length of all the 8 bar. And then if I multiply this by the unit weight of 16 diameter bar, I'll get the total weight of the steel. Pretty simple. So up to here, try to do this calculation manually. Whatever I've explained you do it manually. Apply your logic because in a single go, you don't understand this because you have to break this into 3 parts. First, what you'll do, development length. In that, you will deduct, you'll find this length. Then in the total development length, you will deduct this part. You'll get this one. And then from there, you have to add all these heights. Pretty simple. So try to do up to here. In the next lecture, I'll teach you how to do all these things. So if you understand one column, no, after that, if I give any drawing, you'll be in a position to do that. But this concept you need to understand. Now, there may be a few questions. Sir, there's one bend here. Why didn't you take that? See, again, for a very same reason. Few people add bend deduction. Few people don't do that. If you want to add bend deduction, come here. Bend deduction. Okay, that when it comes to cutting length, I'll explain. Not now, no. Yeah, when it comes to the total cutting length, that bend deduction part I'll explain. Now you carry on up to here. Okay, simple. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So I hope you have prepared the Excel sheet. At least you're done a practice of this. Okay, and here onwards we'll try to do all these things. Okay, fine. So once this is done, we have got this value, this and this. Next is I'll write in the bar. I'll teach you later how to prepare the Excel sheet. First, I'll finish this. Come to the bar description. Here I've written C1 column, which is resting on F1 footing. So how many C1 columns are there? There is only one. So that you can even identify from the drawing also. There is only one C1 column, or even in the quantity estimation sheet, if you go, we have written only one. Number of member is one. So that is the reason I've done an input of 1 here. Okay. Now come to the dia of the bar. What is the diameter of the bar? For that, you have to go back to the drawing. And in the drawing, come for the C1 column. So my C1 column is somewhere here. C1 column. Okay. You can see here. And it's written, you're supposed to provide a 16 diameter bar, the longitudinal bar. How many number? 8 number. So 16 dia, you have to provide 8 number. So what I'll do, I'll come to the Excel sheet. Okay, why it is 12 then? This is C1 column, no? Right, C1 column. Okay, C1 column is here. Okay, C1 column is here. And what I've written? 16 dia, 8 bar, isn't it? 16 of 8. Okay, fine. Then I'll make this as 16. Okay, okay, fine. No problem. It got changed because the moment I keep 16 here, no, everything will change because lap length was depending on this, not an issue. Maybe by mistake I've entered 12 there. Since in the drawing it is 16 diameter, so I've done an input of 16 here. Okay, fine. After that 16. So C1 is here for me. And 16 how many bars are there? 8 bars are there. So we'll make this as 8. So number of bar also I'll do 8. Okay, fine. So the moment I do that, 16 diameter bar, how many bars are there? 8 bars are there. Fine. Next, I want to find the cutting length. How do I find the cutting length? I need to add all the three quantities. So that will be like 14710 plus 330 plus 470. If I do, I'll get the total cutting length. Now you may ask me one question. So this is a 90-degree bend. Why haven't you done that? Again, in the column and all, it doesn't matter that bend whatever you're doing. No, like it's a 90-degree bend. 2D deduction you're supposed to do. Again, for a very same reason, few people follow that, few people don't follow that, but actually it's not required. Okay. If you want, you can do, see, if you want to do here, -2 into D you do. If in a, like I tell, in a company, if they're following, you do that. Okay. But usually it's not required because see, practically that much elongation and all will not happen. That considering that we don't do that. Okay, but if you want you can do, but here I'm not considering that, and you can follow the same thing. But tomorrow when you're working, if somebody says that no, that is not the right way, we are following the bend deduction, then you apply the bend deduction. Okay, fine, because ultimately, like I mentioned, your payment will be done for this only. For example, if I prepare this Excel sheet and in my site the same thing happens, my payment will be done according to 15.51 meter steel only. This much payment will be done to the contractor. Okay, so nowhere we are going wrong. Suppose if you are doing a bend deduction, say 2 into this D, where is the D? 16. So now cutting length has come to 15478. According to that, 109.96 of steel has gone. Accordingly, we are going to make a payment to the contractor considering this. Okay, fine. Cutting length you understood. This is in mm. Now coming to the cutting length in meters. So obviously, whatever answer I'm getting in mm, if I divide this by 1000, I'm getting in 15.51 meter. Now come to the total cutting length. So whatever this 15.51 has come, it's for one single bar. Okay, and for that C1 column. So total cutting length will be cutting length of one bar. If I multiply it by number of bar, how many bars are there? 8 bars are there. I'll multiply. And how many such C1 columns are there? There is one. So this multiply by this will give me the total cutting length of all 8 rebar of C1 columns, which comes out to be 124.08 meter. Finish. So once this is done, I'm supposed to find the weight of my bar. So since there was 12, I had done the input previously, I have written in 12. So I'll delete it and I'll write it in the 16 column. So this is my 16 column. So 16 diameter plus this answer, I'll multiply unit weight of 16. So the unit weight of 16 is 1.58 and enter. Finish. So I got the answer is 196.05 kg of steel is required. Only the column longitudinal reinforcement, this much steel is required for me. Okay. So once this is done, next we'll go to the stirrups part, that is a lateral ties. Okay, everything will go together. First we'll find the longitudinal bar, then we'll find the stirrup, I mean the lateral ties, and that will be complete one column. Okay, fine. Now coming to the lateral ties. Now how you have to do the calculation for that, this I'll explain you in one sheet. Okay, so for that I'll go here, I'll take a blank page and I'll explain you that. So yeah, this will take some time. So okay, now let us consider I have a column, I have a lateral ties. Okay, this is a lateral ties. Okay, and the size of that is given. This is a lateral ties, what we usually put. And here the column size is given. The column size was, let me check what is the column size. Okay, you cannot see the column size also here. I'll come back to here. So the column size was C1 column, no? C1 column, it was 200 by 350. Okay, so it is 200 by 350. I'll write it. So the column size was 200 by 350. So 200 by 350. Okay. One more thing is that you just need to check the drawing, which is 200 and which is 350. So this is C1 column. See, this is that. So your column is like this. Okay. This means this portion is 350, but I have drawn it wrong. See, this portion is 350 and this portion is 200. You will ask me, sir, how did you understand? Very simple. You see the size. This is 300. This looks bigger compared to this. That means your breadth is 200 and your depth, this is called as 350 mm. Okay, then I'll change my drawing then. So what I'll do is I'll go here only. I'll write somewhere. I'll do somewhere here. Okay. So I'll do somewhere here. Yeah. So it is something like this. So it is something like this. This is a lateral test what I'm supposed to put. Okay. So it will take some time of yours to understand the concept, but it is very simple. And what is a column size? Column size is 200 by 350 mm, isn't it? 200 by 350 mm. So how do you find the cutting length? So I want to find this cutting length. See, this is column actually. This is your column. This is your column dimension. Okay. But inside that, it will be a lateral ties. So this cutting length we are supposed to find. Remember, in the column, your clear cover will be 40 mm. So if I want to find this length, if I want to find this inner length from here to here, and I want to find this length from here to here. Okay. How will I find that? I'll explain you how it has to be found. So go to the Excel sheet. You'll see what I've done here. Okay. So where is my, so what happened? Got deleted. Okay, fine. We'll start from here. So how do you find the cutting length of this? First, I'll find this cutting length. I'll find this cutting length. Okay, this is 350 for me. If you want, I'll write that also. Let me drag it out. Okay, this is column size. And this is 350. This is 350. And this is 200. Okay, fine. So first we'll find the 350 side. This length I'll find. So it's very simple. 350 overall length minus from the left side I'll take 40 mm cover. This gap whatever you see, no, this is 40 mm from the left side, minus from here this is 40 mm, this is 40 mm cover, minus. Okay, so when I do this I'll reach up to here. I'll reach to which point? From this outer to this outer. But usually when you find this, so we have to take from center to center. That means actually your bar will be here. Your bar, you will be having a bar here. Okay, we'll be having rebar here like this. This bars will be there. Only then it will look like column, no? So usually what we do, we go from center to center. That is center of this rebar to center of this rebar. You're getting my point? Now I've reached to the outer one. I've reached to this point and I've reached to this point. Okay. So what I'll do, I'll come to the center to center. That is, I have a, yeah, to make it better, no, I've done this particular thing. Now I'll explain you what I actually wanted to tell. So I want to find from the center of this stirrup to the center of this stirrup. Okay, getting my point. So what I did, 350 is outer to outer minus 40 mm cover I've taken out from the right side, 40 mm cover from the left side. Okay, now where did I reach? I reached to the outer of the stirrup. Stirrup outer to outer I reach. But few people, what they do, few people stop there only. So they say this itself is a length. But if you refer Indian Standard Code book, that is IS 2502, this is a code book. So if you refer to the code book, and what we usually practice is we go up to the center. So always whenever if you do to the center, you'll get a better answer, you'll get a correct answer. Again, it is completely depending on the type of the project and type of the company where you work for. But whatever I'm telling, most of the people, we follow this only. We go from center to center. Okay. So that means what is the diameter of this stirrup? It is usually 8 mm. Again, in the drawing, it will be mentioned. So I'll take you to the drawing. Yeah. So it is mentioned here that you are supposed to use a 8 diameter bar. See here, C1 column. So it's a 8 at 200. So 8 is a 8 mm. 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 8 Okay, see, there's some problem. So everything got deleted. Now I need to do it again. So I hope you have understood that. But anyhow, I can't bring that back. I need to redraw it. Give me a second. Yeah, I redrawn it. Okay, fine. So what we did, outer to outer, that is 350 minus left side 40 cover minus right side cover. So what where we did, we reached here. That is the outer of this stirrup to outer of this stirrup. But usually, like I mentioned, we need to take from center to center where we get accurate answers, and that is the right way of doing the bar bending schedule. So if I want to come to the center of this to the center of this, if I this stirrup diameter is 8 if I take half of that, it will be 4 So from here I'll add 4 and from here I'll add 4 So okay, I mean I'll deduct 4 from both the side. One way of understanding. Other way of understanding is you just deduct the diameter of the stirrup. Instead of minus 4 is minus 8. Instead of doing that, whatever is the diameter of your stirrup, you deduct that. Directly I'll do that. So directly I can write minus 8 because I've written the diameter of the stirrup is 8 minus 8. Now you tell me what answer you got. You do it manually. So it is 350 minus 40 minus 40 minus 8. So I'm getting 262 Fine. So this 262 is this length. Which length? This length. 262 is the length from here to here. From this center to this center. Okay. So this will be the cutting length of this side. Similarly, this also will be 262. But now we want to find from this center to this center. That means we want to find this also now. I'll give a different color. I want to find this center. Okay, I'll keep black only. Yeah. I want to find this center now. And from there to this center. Again, same procedure will apply, provided this time your direction, the way you go is different, will be different. Okay, from this center to this center I want. What you will do in that case? Again, same thing. See, I know this length. Which one? This length. How much it is? How much it is? 200 because that is what there in the drawing. So it is 200 no? Where it is? Yeah, 200 and 350. C1 is 200. Okay, you're getting my point, no? So it will be 200. So if you want, I'll write here. This is 200, outer to outer. Okay, 200. This is 200. From where? This portion. This outer to outer is 200. In that, 40 cover is gone. So this is a 40 cover. 40 I'll write here. And here 40 cover is gone. So what is left out? Write it here. So 200 minus 40 from the downside minus 40 from the top side. Okay. Now where we reached? Outer to outer we reached. Minus diameter of stirrup. What is the diameter of a stirrup? It is 8 So now if you do this, I'll come to center, and whatever answer I get, this will be this answer. Got it? Agree with me? Try to do this manual calculation. So again, 200 minus 40 minus 40 minus 8. So I'm getting 112. How much I'm getting? 112 That's so this will be my cutting length. So now I want to find the cutting length. That means if I add this 262 and if I add this 262 from here and if I add this 112 and if I add this 112, will I not get the complete length of this particular stirrup? I'm going to get. But along with this, there's one more catch. The catch is usually your stirrup will be something like this, isn't it? It will have a hook in this way. This hook length also we are supposed to add. I'll teach you that later how to add. But right now, whatever we have done is correct. Okay. Now, this much you understood. I'll delete this and I'll take you to the Excel sheet. So now come to the Excel sheet. Yeah, see here what we have done. Okay. Now, in the Excel sheet, I've written here ties. We call it as lateral ties. How many numbers? Same. Whatever number of column will come, same will be a lateral ties. Okay. Only the thing is the diameter of your lateral ties is usually 8 that you can find from the drawing. So it was written 8 for C1 column. My lateral ties. This is main stirrup, which we took 16 diameter 8 bar. For stirrup, it is mentioned 8 diameter at 200 center to center spacing. So I'll come back to the Excel sheet. So I'll input here 8 and I'll input the spacing as 200. This much you're supposed to do. Now this length, how did I find? Very simple. What I did, if you want, I'll do again here. What I did, plus what I did. First, I took the size of the this thing, which is that column. So I took 350 minus left side 40 cover minus right side 40 cover minus diameter of the stirrup. So diameter of the stirrup was 8. I clicked on it. I hit the enter button. Did I get 262? I got. Next, what I did, I brought it to the center. Finish. I brought it to the center. Got it? In this way, you're supposed to do that. So I'll delete it. I explained to you here. Whatever I did, I just interlink that here. Nothing. What you're supposed to do, whatever you got, come here, keep your mouse here. You know all those things now. But anyhow, later I'll teach you to prepare Excel sheet and say plus 262, finish. You, okay, you got that answer. Done. Now come to this side. This side also you know how you did this. I'll do it here. For this side, what I did, yeah, this side what I did, plus what is the this thing, length was there, what is the breadth of that? So breadth was 200 minus 40 mm from the left side, 40 mm from the right side, top 40 minus 40, and then one diameter minus, I told, diameter of the stirrup. I'll get 112. Manually also I got the same thing. Agree with me? See, 112 I got and 262 I got. Same thing in the Excel sheet I got. Okay, this much is understood. Great. So this thing, next if I add everything, next if I add this 262 plus 112 plus 262 plus 112, I'll get the total cutting length. But I told you we have something called as hook. This hook also we need to add. Okay. So how do you add this hook? That I'll tell you. Finish. Up to here it is clear. You understood the spacing. Now we'll find the number of bar. What we'll find? We'll find the number of bar. Means, for example, practically. Okay. See, you can see a lot of stirrup given here. A lot of stirrup, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many stirrups are there? So many stirrups are there. How you'll find how many stirrup is required? So for that, what you do? Very simple. For that, you have to take the total height. For that, what you're supposed to do? Okay. Okay. We'll start from here. Okay. Else I can take this in the next lecture also if you find it confusing. Anyhow, I'll explain it here. So how do you find the number of bar? So always remember, whenever you put this rebar, this stirrup will start from the bottom itself. Okay. So what I have done, from here it will start. I explain you from here. Okay. This stirrup you are going to start from here. Okay. So it will be from footing. Yeah, from footing. From here itself only it will start. From here itself only your stirrups are going to start. It will go till the top of that. Okay. So for that, what we have done, we know this height. Yeah. Okay. I'll check what I've done. See here, and C13 is here. Where is C13? Okay. C13. Minus D13. Okay. C13 is here. No? Okay. Fine. I'll explain how it has to be done. I'll start from here. Plus, I'll do open bracket. Okay. What was the depth of the excavation? It was 2500. 2500 minus what I'll do, one cover I'll take out, because directly this lateral test will not start from the bottom. One cover you'll leave. So minus 50 I did. Minus on the footing, we had provided a shorter diameter bar and longer diameter bar. That also I need to deduct. So that means minus, I'll do this one. This 10 dia minus this 10 dia I'll do. So if I do this, no, everything is finished. Okay. So I'll close the bracket. I'll hit this answer. So what I planned is I'll explain you here. So there's one drawing which I need. Let me find that drawing. Yeah, you understood now what I did? See, what I did is, this is actually a footing for me. Okay. Let us say my footing height is up to here. Okay. This is from here is my ground level. From here, my excavation is going to start. Okay. So this was actually 2.5 meter, if you remember the drawing. So 2.5 minus, you'll see this lateral ties what we have. No, this is your lateral ties. It is not going to start exactly from the bottom. It will start from here. This is the first lateral ties we are going to find. Okay. So that is why what we did, we took overall depth, that is 2.5 meter, minus your bottom for the footing, you'll give a 50 mm cover, minus, you can see this shorter span 1 diameter and longer span diameter. If I do, I'll get the height of this lateral ties. That is the first lateral ties height from here. Getting my point? That is why I taught you this is how it has to be done. So what I did, I'll go back here. I'll explain you once again. So what I did, 2500 is the depth, what was there in the drawing, minus the bottom cover 50 mm, minus the lateral ties in the shorter span, I mean minus the footing shorter span bar and the longer span bar. Got it? Fine. After this, very simple. Now by doing this, where did we reach? By doing this, where did we reach? We reached up to the natural ground level. That is till the bottom of the plinth beam. After that, you should add the height of the plinth beam plus first floor, second floor, third floor. If you add all the height, you'll get the total height. Very simple. So what I'll do, plus 350, that is the depth of your plinth beam, plus 3300 ground floor height to first floor to second floor, and from there to the last one, it is 3300. Okay, 3300 plus 3300. Enter. How much you got? I got 12,680. Okay, and how much did I get here? Where was that? Yeah, it is here. Later I'll divide that. Okay, same thing I did. See, plus 350 plus 350 plus 3300 plus 3300 plus 3300. Last one thing we didn't do here. What was that? That is in this, whatever height I took, that I took till the top. But there's small 40 mm cover you need to leave, no? Because your stirrup or the lateral test will not go to the full top. From here, you'll give a gap of 40 mm and it will stop only up to here. So that is why what we'll do minus 40 mm. Okay, minus 40 mm. So this is the overall spacing we got. Overall height we got. If I want to find the spacing, this height, if I divide by the center to center spacing, how much it is center to center spacing? It is 200. I'll get the number of bar. Obviously, I'll get. So what I'll do, I'll take this value now. So I'll write here plus open bracket this value. Okay, I'll divide it by which one? 200, and I'll close the bracket and I'll say plus 1. Okay, because you're finding the lateral test. You know that whenever you're finding the number of bar, you need to add 1. I'll hit enter. How much I got? 64.2 I got. Here I got 64 because I wrote this thing, comma and 0 I given to make it round figure. I can do that also. I've done a roundup of that. Okay, so if you do that, you'll get the right answer. So here I got 64, here I got 64.2. But anyhow, you follow this. I mean, I explained you in 2 steps. Now you understood the concept. I'll put it in one single step and explain you. How did I get this 64? Come here. First, I've done round up 2500 overall depth minus your bottom cover 50 minus shorter span diabar minus longer span diabar. Okay, fine. Plus 350 is the height of the plinth beam plus 3300 ground floor to first floor to second floor, and then third floor, that is your roof floor. Minus 40 is for the cover we have to do. Minus 40. Whatever answer you get, this should be divided by the spacing. What is the spacing? We had 200 mm spacing. And then comma and 0 to make it round figure. Otherwise, you'll get like 64.1, 63.1. To make it a round figure, I have given dash and 0. I have closed the bracket. Finish. I got the answer. So totally, I require 64 lateral ties. If I want to do the complete column of this height, if I want to put the lateral ties, how many lateral ties is required? 64 number is required. Simple. Good. Now once I found this, next what I'm supposed to find? I'm supposed to find the cutting length. I'm supposed to find this cutting length. So in cutting length, you know, you need to add 262 plus 112 plus 262 plus 112. But how do you measure this? This ring, this hook, whatever you have, no, this hook. How do you find the hook of that? Okay. So that hook I'll teach you in the next lecture how it has to be done. I'll stop my lecture here. Otherwise, it will be a very long lecture. So up to here, you practice whatever I explained you. Okay. And in the next lecture, I'll teach you how to calculate this hook. And later we'll finish this particular thing. So once we understand this, after that, I'll teach you another lateral test, how it has to be done. So if you do this, no, one complete column I will explain you. Okay. After that, I'll explain you once again in a very detailed way. I mean, overall, I'll explain you. Right now, I'm breaking down my lecture so that we'll understand it part by part. So it's very simple. To find the lateral test, you've understood how it has to be done. This hook part, I'll explain in the next lecture how it is to be done. Okay. So practice up to here. Try to do it manually, learn it, and in next lecture, we'll finish this. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So there is a code book by name IS 2502-1963. You can even download it for an Indian Standard code book where it has given a formula. That means what it is trying to tell us, if you're using a stirrup or a lateral tie, something like this. Okay. So this is how it is. Then how do you find the cutting length? It is already mentioned. So this is a shape what we have, isn't it? So this is a shape what we have exactly. And it is telling us that this is a formula you need to apply directly. That means 2 into a plus e, where it is mentioned that this is a, where it is mentioned it is a. See, this is a, okay, and this is e. So 2 times a plus e plus 24 into d. If you apply this formula, you'll find the total cutting length. And one thing you observe, what he has shown here, that is very important. What he has shown from the center to center, isn't it? And how did I make you calculate? I made you this A, whatever he is mentioning. It is from this center to this center. That is center of your stirrup. Okay, this is A. And in the same way, this E, what he has given, even that is also from center to center he has given. Okay, that is actually from center to center. Got it? So that is the reason we can directly use this formula now. That is 2 into A plus B, which we already done. We have got the top as how much did we get? 200 something, right? 262 plus 112. This hook length directly will add this formula, and that formula is 24 into D, and where D is a diameter of the bar. Got it? So this is what we are trying to do. Simple. So first I'll explain this. After that, I'll explain you one more method where few people follow that also. Okay. Now come to the cutting length. I'll do it here. Cutting length. This I'll remove it. Cutting length. I'll do it here. Plus open the bracket. Okay. So add this 262 plus 112 plus 262 plus 112 plus 24 into D, you take it directly. 24 is a direct value which is there in the code book. So you write 24 into D. D is the diameter of the rebar. That is, we have taken 8 mm bar, isn't it? Yeah. If you want, you can open the bracket here so that it will do the correct, it will apply the correct board mass and hit the enter button. Finish. 940 I got. Here also I got 940. Got it? Now, why no bend deduction has been done? This bend deduction is not done because this formula is directly given. So this formula is directly given. So here there is no bend deduction to be done. Now there is no bend deduction because this is from directly from the IS code book. So this 24D includes all the bend deduction in that. So that is why this is not required. You don't have to apply the bend deduction. Got it? Fine. Now, once this is done, next is finding the cutting length. This is 940 is in mm, no? I want to find the cutting length in meter. Again, 940 divided by 1000 will give me 0.940 meter. Now, total cutting length. So this 0.940 is the cutting length of one bar. How many such stirrups I have? 64 number of stirrups I have. And how many such number of columns I have? 1. Therefore, total cutting length will be how much? Exactly 0.94 multiplied by 64 multiplied by 1 will give me the total cutting length, which comes out to be 60.16 meter. Now, since we are using a A diameter bar and we have got a cutting length of 60.16, can you not find the weight of the bar? Obviously, you can find the weight of the bar will be 60.16 into the unit weight of 8 mm bar is 0.395. If I multiply that, no, I'll get it as 23.763 mm. Finish. That's how you're supposed to do. Now, you may have few doubts. We have seen people doing, instead of doing, here I took directly from the code book 24 into D. So what few people do is that they don't do 24 into D. So usually this length, usually this stirrup length, whatever hook length what we have, no, this length, usually sometimes in the drawing it will be written in few of the drawing, and few people practice this to be minimum you have to take 75 mm, minimum 75 mm both the side, or there's one formula which is 10 times the diameter of the bar. It should be minimum 75 mm. Few people follow that. Few people use a formula of 10D. So 10D. Let us say I'm using a 8 mm bar. So 10 into 8 is 80 mm. So I'll take 80 mm instead of take 80 mm. Okay, getting my point. So that means this will be 80 mm one side hook, and the other side hook will be also 80 mm. So 80 will be how much? 160 mm. So people do that also. That is also right method. Otherwise, if I do 24 into 8, what will be the answer? 24D I took, no? I hope you're able to understand. Okay, there's no confusion here. So I'm getting 192 mm if I do this. And if I do this 80, it will be 160 mm. So 30 mm difference will come. So no problem. Whatever you practice on the side, that we are supposed to do. Okay. Now on your site, if you're using this method, that is 24 into D, your billing will be done according to this. If the client and the contractor and all agrees, no, we'll go with the minimum 75, you can go with 75. I mean, minimum 80, 10D. Then you can go with this formula. But in no case, it should be less than 75 mm. So that is written in the code book. So in no case, this should be less than 75 mm. That I'll show you. Where it is, these are the different shape that is given. Based on it, how the BBS is to be done. Okay. So you can follow both things. I'll do for both of the thing. You can follow whichever you want. Yeah, see, here it is given. Forget about this. but not less than 75 mm. That hook length should not be less than 75 mm. Minimum it has to be 75, or you can take 10 times the diameter of the bar. If you don't want to do that, directly add 24D, and then no bend detection has to be done. Got it? No? Simple. If you want, I'll do that also now. So if you want to apply that formula, I'll do that also. What I'll do, 262 plus 112 plus 26 plus this one plus this one. Okay. After that, what we are supposed to do, plus 10 times the diameter of the bar I'll do. So 10 into how much? 10 into 8 mm plus 10 into 8 mm. Okay. Why 2 times? Because 2 hooks are there, no? So that is so if you want, you put this in bracket. Okay. So that it will get right answer. Got it? So it will come out to be 908 mm. Okay. Of course, it will come 908 mm because it will fall short. This is one way. There are people. Now there are also people, those who add the bend detection also. That means again, open bracket, what you'll do, 262 plus 112 plus 262 plus 112, bracket close, plus hook length will be 10 times the diameter, 10, 10, I'll do 20 times. Okay, 20 into diameter. Diameter is 8. Okay, then bend detection they are going to do. Why? They say here there is a 90-degree bend, 1, 2, and 3 90-degree bend. And this is 135-degree bend. Getting my point? So there are people, those who do that also, minus 3 90-degree bend. 190 is 2D. So 3 90-degree means this is 90-degree bend. 1. This is second, this is third. So 3 2s are 6. So 6 into D. 6 into 8. Okay. I'll put that. Okay. This one. Minus this bend, what we have now, this bend, this is a 135-degree bend. It is bending in 135. So for 135, I told you that you should take 3D. If it is 45, it is 1D. If it is 90-degree, it is 2D. If it is 135-degree, it is 3D. So how many hooks are there? This is 135-degree, 135. Two hooks, 135. So if 135, if 135-degree is 3D, 3D plus 3D, 6D. So minus, again, open bracket, 6 into D, diameter is again 8. You're getting my point, no? Close the bracket. So all of you are correct. Now, whatever you have on your side, you can follow. If you're following this, like I explained, 24 into D, this will be on cutting length. If you're applying the hook length, you're taking minimum 10D, 10D, you can follow this. There are people, those who apply the 10D and also do the bend deduction, then you follow this. Now, whatever you follow here, the same building will happen. That's the final conclusion. So none of you are wrong. So you may, before taking my lecture, you might have seen someone doing this kind of method. Before taking my lecture, you might have seen few people on YouTube, or maybe your seniors, or maybe anywhere you might have seen people doing. So I've taken all the 3 cases. Okay. So always people refer this IS 456 method because this is directly given in Indian Standard Code book. Okay, this is that code book where it has to be 24 into D. So this is a perfect method. And if somebody asks you for the logic, you have the proof ready with you that this is what the code says. And based on that, I have gone wrong. So if you want to prove me wrong, make this, whatever code is there, you prove this wrong, then my answer will be wrong. Because 2 into A plus E plus 24 into D. So that is why first method I have gone with that only. 940 is the right answer. This is also correct. This is also correct. So it's like 2 different school of thoughts. And I've given a lot of explanation for that, where when the load coming on a beam is, let us say, 11.5 kilonewton, some structure engineers consider it to be 12 kilonewton based on his experience. Some they say that, okay, 11.5 only will come. He'll take 11.5 and design his beam. There are few people who say practically 11.5 doesn't come. We'll take it as 11. So all 3 people are correct, right? The same thing. But ultimately, whatever you do here, same has to be executed. If you're doing this bend deduction, if you're doing 24 into D, 24 into D, then practically cut your bar according to that and do the execution. If you're doing 908, then you do the same thing on the side. If you're doing this one, bend deduction, do the same thing on the side and get the same thing. And when the contractor has to bring the same thing for the building, that's how it is. Okay, fine. So I've explained you all the 3 methods. Now it's up to you to decide whichever you want to do. Fine. Now the last part what we have is a links one. So this link one, what is this link? I'll explain you. So for this, I want to show you some images. Yeah. Now in our drawing, we have 2 kind of lateral tests. One is called as mastering, which we have done completely. Then there is one more guy. Then there is one more lateral test, which goes something like this. Okay, this one, it will be like this, coming like this and coming like this. So we need to find the cutting length for this also. So practically how it looks, I'm showing you an image for that. Already basic course if you have taken, I've covered all these things there. I've explained you how these things is designed and all those things. So if you see here, see in center portion here, here you can see that a kind of a hook is given. So in this way, practically they give. So in one column, if your column is huge and all based on the requirement, because based, see, this is a criteria to decide all those things. If you go to SP34 code book, all these things are given. When you have to use that single tie, when you have to use two ties, when you have to go with a group of three ties, everything is there. That was covered in my basic class. Okay, that is site engineer construction methodology class. Okay, now you see here, here also, this is one hook. Okay, it has gone inside, you cannot see it. Same thing here. Okay, you getting my point now? This, so this cutting length I'm supposed to find now. Same thing here also, it is there. This one, fine. Now how do you find this cutting length? Very simple. This cutting length, what you're supposed to do, whatever you get here, no, same thing you have to write here. Why? Because wherever is this breadth side, this one, okay, same thing is this one. Okay, so whatever is this one, same thing will be this one, for a very same reason. If I take the column dimension, so our column was something like this, isn't it? So this is how our column, this is how our column was. Okay, and yeah, this is how our column was, and this lateral ties will be placed in this way. Okay, it will be placed in this way, in this way. Okay, and then I think one mistake I've done, I'll change that mistake, not an issue. Then this will come like this. Okay, if that is the case and small mistake has happened, okay, then what will happen, then whatever is this length, no, that I need to take. That means it's 112, not 262, it has to be 112. No problem, I'll change it. This one it should come. Yeah, now it's correct. So okay, actually I should have drawn it in this way, it will look like this. Okay, so it will be placed. Okay, I'll show you here. Practically it will be placed like this. Okay, practically it will be placed like this. So whatever is this length, no, whatever length we got, that is 112. This also will be 112. So that is why I have written 112 here. Simple. Got the idea, no? Why, how it is placed? Yeah. Next, I want to find only this hook length and this hook length. If I add to this 112, I'll get the total cutting length. Number, same number. Whatever number you got here, same number. Because this rings, whatever you place, no, if you're putting in the group, if there is three groups, like one master ring, then this one, it will remain same. Okay, so you just have to interlink this, and spacing and all, everything will remain same. So I've written here link for C1, you call this as link. So 8 diameter was 8, here also I've written 8. So spacing was 200, here also it is 200. Number of, we got 64, same thing I've written here. So I've interlinked all these things. Okay, so the moment you get this answer you'll get, only the cutting length will change, and that too you need to add this hook and this hook, whereas this part is already added. This part, whatever you have, no, this and this is same. Got it? Fine. So now how do you find this hook, this one and this one? So this and this hook, where do you get the answer? So for that, the answer is, you need to come here. Yeah, yeah. So this one, this length, how do you find? I'm asking you this length. So this length, it is bent in 135-degree. So from what is the length of this? So again, for that we have to go back to the code book. So in the code book it is mentioned how much you are supposed to take. So if I come here to the code book, so it is written here. Okay, so this is how it is, this is that particular shape. Okay, see, this is L what we take, and this is H, this entire thing we consider it to be H, and this entire thing we consider to be H. This is what we are supposed to find. So it is given here directly. Yeah, how much you have taken? 13D. Okay, yeah, so it is given here, hook allowance. Okay, so what they have written, so they have written hook allowance is taken as 9D, 11D, 13D, and 17D for K values 2, 3, 4, and 6 respectively. So what do you mean by this? It is written hook allowance is taken as 9D, 11D, 13D, and 17D for the K values 2, 3, 4, and 6 respectively. Now what is this 2, 3, 4? So according to the code book, according to this code book, they have classified. If your K value is 2, that means it is in case of mild steel. If your K value is 3, it is in case of medium tensile steel. And if your K value is 4, it is for the cold twisted bar or HYSD bar. That means I'll explain you here. See, your different categories here. This is your mild steel. Okay. Then you have medium tensile. This is your 3. And this is your 4. This is your K value is 4. So that means now whatever bar we are using in the market, they all are CT. That is cold twisted deform bar. CT, cold twisted CT, right here. Cold twisted deform bar. We call this as CTD bar, okay? Or you can call it as HYSD bar. So that falls under this category. That is cold work steel bar, conforming to IS 1786. So if you are using that bar, in that case, your K value is 4. And for the K value 4, you have to take 13D. See, again, I'll tell you. I'll write here if you don't understand. So first, I'll make 2 columns. Okay, let me make 2 columns. Okay, and I'll explain you. It's very simple. Just the fundamentals part I'm trying to make you understand. That's it. Only once if you understand, you can carry on with that. This is for 1 K value, second K value, third K value. Then we'll go for the last one. Okay, fine. So I'll write here, if my K value, if my K value is 2, this is for K value 2, this is for K value 3, this is for K value 4, and this is for K value 6. Okay, I'll write here K. This is for K, and this is for hook allowance. Okay, okay, fine. This I'll write hook H. So it is written 9D. So it is 9D. Then it is 11D. 11D. Then it is 13D. And this is 17D. Okay, now you understood. See, I'll explain you. What does it imply? Right now, we are just concerned on this cold work because that is the bar what we usually use in the structure nowadays. It is called a CTD bar or HYSD bar. So if you're using a HYSD bar, it says that it falls under the category 4. So this is my category 4. So from where did I come to know? It is written here, 4. See here, 4 in the case of cold work steel firm conforming to IS 1786. This much is clear. So that is falling under 4. Now, if it is falling under 4, then it is telling that you have to, where is 4 my? So if my K value is 4, what I need to take? H value will be 13D. So that hook length, what I'm supposed to take, this hook, this one, what I'm supposed to take is 13D. That means this is 13D on the left side. This will be 13D. And this is 13D. This much is clear. That's it. This is what I wanted to tell. And where was it written? It was written here. But again, this should be minimum 75 mm. Minimum 75 mm. So it is written minimum 75 mm. So directly they have given. What is the diameter of a bar we are using now? 8 mm bar. So directly, these people have directly given what should be the minimum length you are supposed to use for 8 mm. So I'm using for 8 mm. Okay, this is 8 mm. And under the 8 mm, look what is the answer I'm getting. This is 8 mm. I'll make a different color. Yeah. So I'm using a 8 mm bar. I mean, wait. Yeah. I'm using, yeah. I'm using a 8 mm bar. And for 8 mm bar, what is that pension? 105. Okay. How did it come to 105? Very simple. What is 13? 13D. No, I told 13D. So 13 into 8. You do what is 13 into 8? It is 104. 13 into 8 is 104. That's it. So 104. And the code is saying us to take 105 mm. So this should be 105 and this should be 105. Simple. And if it is 10 mm, obviously it will be 130 because 13 into 10 is 130. It is mentioned 130. If you're using a 12 diameter bar, you have to take 155 because 13 into 12, right? Yeah, 13 into 12 is this one. That is how the answers are coming here. Simple. So now don't scratch your head anything. Just remember you have to take 13D. And from where did that 13D came? I gave all the explanation. Got it? Nothing. Go back to the Excel sheet. And here, come here. So spacing will remain same. Number of bar will remain same. You'll see here what I have done. Okay, this one. 104. Why, from where did it come? I written here 13 into D. What is D? D is 8 mm. So how much I got? 104, 104. What did the code recommend? The code recommended us to take 105 minimum. Where is that? 8 mm. It was 105. 105, we have taken 104. If you want to take 104, you directly write 105 also here, no problem. Okay, so 104, 104 and 112. So the total cutting length will be again same, 104 plus 112 plus 104. Again, no bend deduction, because directly from the IS code we have taken that value, so no bend deduction to be done. Okay, fine, that's it. Now cutting length will be 320. You divide this by 1000, 0.32. Now this is a cutting length of 1 bar. This 1 bar cutting length I have got now. So total cutting length will be 1 bar cutting length multiplied by number of bar into number of member will give me the total cutting length. And weight, since it's a 8 mm bar, it has to come in the 8 dia column. So 20.48 into 0.395 will give me the total weight of the bar. Finished. That's it. Your bar bending schedule for one column I've explained. So it took so long, but it is very simple. You have understood the concept. Fine. Now, if you ask me, tell me the total steel, you just have to add. I mean, I'll add it later when I finish everything. But for at least for C1 column, if somebody asks you how much steel is required, just write here. So what we'll do is we'll make a column here only. I'll drag this and merge it and just add everything. Plus this one, lateral ties, rings, plus 23. Okay. Plus this one, plus, where is that last? Yeah, 196. This one, no? Correct. 196, fine. Enter. So almost 227 kg of a steel is required for C1 column. If I want to do C1 column, main bar, longitude, lateral ties, first lateral ties, and the links, I require 227 kg of a steel is required. That's it. So this was a complete BBS for the column. Now after this, I'll teach you how to prepare the Excel sheet in the next lecture. Then rest all things, I'll explain you overall how it has to be done. You understood the concept. Rest things, I'll explain you for everything, but it remains the same. Nothing changes. You just have to copy paste. Like you'll copy again. Next from here, you copy everything like we did in the footing. No, same thing. Copy and then Control C and paste it, and then come to the drawing, come to this estimation drawing. Now next we'll consider C8, C12 and C25 columns. So 3 columns are there. In that case, what you will do, you just have to mention 3 times. Yeah, so you see, like I mentioned here, C8, C12, C25 on F2 footing, and 3 numbers are there. So here I've done an input of 3. That's it. Got it, no? So in this way, you have to finish the complete BBS for the G+2 building. What I, for that drawing is given here. You have to look into the drawing, and based on that, this drawing I've done modification. Okay, just to make our calculation easy, and later we'll take the difficult part. Now it's easy. Fine, good. So in the next lecture, I'll teach you Excel sheet, and then we'll finish everything. And then one lecture I'll take where I'll explain you all these things in a even better way. Okay. So all your doubts I'll solve. In spite of this, if you still have doubts, you can always get back to this number 9953779047. Okay. Plus one you can add here. And else, if you don't want to get on the WhatsApp, you can get on the mail. Akshay Kamath, AKSH AYKAMATS73 @gmail.com. If you mail, if you have any queries, if you're not able to understand anything, I'll get back. You can contact me here and I'll solve your doubts. So we'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. So here we'll see how the Excel sheet has to be prepared. I hope up to here you have prepared it. Okay. So next, what we are supposed to do in the shape of the bar option, what we'll do is we have to write the footing name, then we have to write the column name, and then the shape has to be done, right? So that's what we are going to do now. Same thing. I've written the column name. Like I read to write like this. With C1 column on which it is resting, like C1 column on F1 footing. Then this footing, I'll make it like this, and this I'll make it like this. That means in the shape of the bar, on the left and on the right, I need to add 2 columns, which I deleted, but again, I think I need to add it again. Okay, but not an issue with add it. So I'll click here, I'll say insert, and then again, I'll click here and I'll say insert. I think that, okay, I should keep here and I should say insert. Okay, done. So 2 columns has been inserted, and next we can merge it. Okay, this 2 I'll merge, and I'll say merge at center, and this is for the footing, I'll keep it. Okay, and after that, we can reduce this size a bit. Yeah. So I'll write here, what is the first thing I need to write? C1 column. So I'll write C1 column on F1 footing, on F1 footing. And there you need to write Why I'm telling you to write? Because it is easy for us later. 200 by 350 is the size of my column. Okay, you write this also, so that every time you don't have to look into the structural drawing. Okay, yeah, so then you can change all this color and all, try to do it. Okay, fine. Next here you write the footing name, that is your F1 footing. What was the size of my F1 footing? So F1 footing was 1200 by 1200 by 400. Okay, so I'll write 1200. So I'll write F1. It is 1200 by 1200 by 400 Okay, this is my footing size. Bring it to the center, make it bold, and do this. Okay, fine. Then next, done. Okay, you know all these things now. You're expert now. So just input that 1200, and you input 1200 here and input 400 here. So it will be easy for me to interlink later. And now again, what we are, you have to write the diameter. No, yeah, one thing, that one we have missed. So diameter, okay, I'll write in this way. So I'll drag this, I'll drag it, and I'll say merge at center. See, it all depends on you how you want to create the Excel sheet. There are people, those who don't do like this directly. They every time they look into the drawing and do all these things. But I feel this is one easy method where you can do everything, small changes, and you'll get the right answer every time. Okay, so try to follow this only. If you have your own way of doing, you can do that. Okay, because there is no fixed rule, there is no hard and fast rule. Whatever I'm teaching, same thing you have to do. No, if you have something else, creativity, if you're very good in Excel, yeah, you follow your own method. End of the day, we want the answer to be same. That's it. Finish. Yeah. So once this is done, everything is ready. Next, we have to go with the bar shapes and all. So this kind of bar shape has to be done. Okay, and then the column size I've written. Okay, this for lateral test will do. So now what I'll do, I'll select this. You know how it has to be done. Select in this way. Okay, and then come here and make it as white color. Finish. So this entire thing has got a white color. Now you draw the shape of the bar. How do you do that? Shape of the bar. You can come here, and I think you can come here and say draw border, and you can do it in that way. But again, this length you cannot do in that case, and it will be a very big length in this case. So that is why I told you, all the time this method will not work out. You can even reduce this, but again this will come down. Okay, instead of doing all these things, don't do. Simple, come here, insert, go to the illustrations, go to the shape, go to this option, and then you can drag one line, something like this much is enough. Okay, and make it straight. If you want to make it straight, click on the shift button, it will be straight. And then again, take again, otherwise you can copy the same thing, control C, control V, bring it, and you can select it in this way. Okay, so this will be a kind of a L shape. Yeah, so just try to merge it. Yeah, so it looks good, no? Fine. So once it is done, select this and select this. When you want to select the second option, if you directly click, it will disappear. So click the control button and click on both. So both will be selected. And then you can go to the shape option, shape outline, come to the weight, increase the weight of that. Color, if you want to make it red color. If you want black color, make it black. If you want blue color, make it blue color. And after that, if you want, no, just bring it closer and you can group it. Group it means, for example, what is group it? Group it means, now if I want to select this, I cannot select it as a single unit. This is separate, this is separate. So when you group it, no, it will act as a one unit. That means I selected this, and control button, I selected this, and right click your mouse. So once you right click, the option called as group, and select the group. Now see, this is the single unit. I can move wherever I want. See, I can move this, select and move. I can move. And if you want to copy, control C, control V, see, same thing is copied. You can add for the next footing. Okay, so that is why grouping is to be done. Yeah, once the grouping is done, just to bifurcate, just to get that idea, where is your GL level? So just click on this. This is your top of the foundation. What is this? This is your top of the foundation. You don't have to write. If you want, you can write top of foundation. If you want, you can write, so that you can get an idea. Okay, this is my up to the foundation length. This is my that L shape, and from here to here to the top of the each floor, first floor, second floor, and all. Got it, no? Fine. So once that is done, next is very simple. Next, you just have to do this thing. What is that? Select. You can just write here C1 column. Just put one this thing, uh, border, all border. If you want, you do it. Okay. all border, yeah, border will come, and just you can start writing here. If you want, you can take 2 and say merge at center, and then keep on writing all these things. Okay, I'll write here now. So what I'll do, column C1 bar longitudinal reinforcement I need to find. So C1 column, C1 column longitudinal bar. Okay, C1 column longitudinal bar. So it select on that, go for the wrap text and make it bold and change the font of that. Okay, yeah, now it looks good. Fine. Now first is number of member. How many members are there? I'll write in this way. Okay, else I'll unmerge this and I'll go with a single thing only. Okay, okay, wrap text will not work out. No problem. I'll increase the size of this. This I'll decrease, and this also I'll decrease. Yeah, fine. So in single thing will. So number of bars, C1 column only one is there. I'll input one here. Dia of the bar, it is a, I think it's a 16 dia bar. If I'm not wrong, I'll go back here. So C1 column, it was a 16 dia bar, 8 no? So come to the Excel, 16 dia. Okay, fine. How many bars were there? 8 bars are there. And what is the spacing? Spacing is not required in the longitudinal bar. You make it dash. You write dash and enter, or you can leave it blank also. You can write dash here. Okay, now find the cutting length. So cutting length, how do you find? You know. Okay, now we didn't do all those things. No, this you know how to write. No, yeah, this I didn't teach you how to write. Fine. So this what was the length we got here? This, how do you get this length? Or should I teach you once again? Not required. No, I'll just directly write the values. Okay, I'll not teach you again how to do. You already know that. So just let me see what values I had got initially. Okay, so this was 470, 330. So I'll write 470 here, right? 470, whichever cell you want to, you can take. You don't take this. Take the cell which is very near to this one. So write 470. So it will go here, click on that and bring it to the left, or bring it at the center, or bring it at the left. Okay, now it's not looking good. No, it has gone here. So just try to align your this thing, finish, align it. Getting my point? This is how you have to adjust it now. Okay, 470. Next, this was how much? This was 330. You know how that 330 and all, right? 330 here. So it is somewhere here. So bring it to this point. So it will go out. So if you bring here, it will go out. So in that case, again, try to adjust it. And this you can try to bring at center. Okay, it will go to the corner then. Then this, if you bring here, okay, then also not possible. You write here 330. And then you bring it center, bring it left point. Okay, then again it will create problem. No, so in that case, what you do is, yeah, okay, fine. And this one you bring somewhere here. Else, what we can do is, we have one more option for that. You bring it here, and this you need to just drag again. Hmm. So this is one problem here, but no problem. That will get adjusted. If you had selected the cells properly, then it would have been correct. Okay. Now I think I need to change a bit. So I think I'll write here 470 and let me bring it the center. Okay. Now it's okay, not an issue. It doesn't look so bad. It's understood. Okay. This is, if you understand, it's enough. This is 470 and this is 330. This, if you want, you can bring it down also here. 330 you can bring here. Now, okay, now it will look good. See, now it is fine. No, 330 has come there. This is 330. This much length is 330. Okay, this is 470. Fine. Okay, yeah. And now this will be the remaining portion. Remaining portion, what you do? Remaining portion, how much it is? 14710. So write 14710. You know how it will come. Click on that and go to the left option. Okay. Yeah. Again, you can drag this a bit little here. Okay, now it will look good. No problem. Okay, you can go with this. Got it now? How it has to be done? I did it by utilizing my proper time. I have done that. Since here it will take some time, but it's okay. This much also, if you do, it's enough here. Okay, fine. So now what all we did, yeah, this is not getting freeze. No, see the moment I go down, this is not visible. So what you do, you have to freeze it. Select here, go to the view option, go to the freeze panes and freeze it, finish. It will be freeze now. Now it's visible. Fine. Spacing is not required. Cutting length. Cutting length, how you find? Plus this cutting length plus this plus this. So total cutting length I'll got 15510. Same thing I got here, no? Exactly. Fine. Same thing I got. Now cutting length in meter will be plus this one. You divide it by 1000. Okay. Fine. You got it in meter. So total cutting length will be plus this cutting length multiply by number of bar multiply by number of member. Finish. You got 24.51. Okay. Okay. So yeah, total cutting length. What mistake I did? Mm-hmm. So why is that it's not matching? 16. Let me 147 330 470. Okay. So this is 15.51. 15.51. Okay. Will plus 15.51 multiply by number of bar multiply by number of member. Okay, now it's correct. See 124.08, 124.08. Got it, no? Sometimes that happens. Now, since we are looking for a 16 dia bar, we have to put the value in 16 dia plus 124.08 multiply by unit weight of 16 dia, which is 1.58. So it is 196.077. Same thing, 196.07 we got. Okay, great. Everything is done. So now you, if you want, you can just make this good. Like click on the bold option, then use that proper font and bring at the center, and that's it. So this is how it is. Then again, if you want, you can make it good. Okay, I'll not do, select this, select this, select like this, select like this one, this one, this one. Anyhow, we'll do it. This one, then this one. Okay, then this one and this one, merge at center, and now you take to the second, give a proper font to that, and then put them in a proper this thing. Finish. Now it will look good. Done, no? Finish. So this is one option. You're done. Again, this thing is not required. This is, you'll say no border to this. Border will be border will disappear. Select this and give a thick box. Finish. Done, no? Again, this top option also it's not required. In that case, you can select like this, and if you can select and you can give a white color to that. Okay, give a white color. Okay, so this border has to go. Select that and say no border. Okay, done. Now again here border will disappear. Thick outside border. Here also border will disappear in this portion. Select that and give it. Okay, fine. Rest things you know how it has to be done, isn't it? Because all this you know how to use it. Because here directly I've done an input, but you have to make use of this this thing, that is a depth of the footing, this dial to take care of all this 330, 410 and all. That interlinking you have to do. Like here I've done that interlinking, no? 470 I got, like how? How did I get this 470? That is 15 to diameter of the bar minus this value I did. Okay. So these things you can do, no? Just in case, anyhow, I'll do it. Because when I'm teaching, I'll teach everything again, not require all those things. Fine. So first what we'll do is we'll find this length. So if I want to find this length plus, I have to open bracket. So what is the depth of my footing? 400 minus 50 is my cover minus 10 dia and minus 10 dia. Okay, close the bracket. Yeah, 330 I got. Same thing we got na 330. Yeah, and this will be how much? This will be plus, open bracket. Your development length is 50 here. You multiply this by 16, 60. Okay, and minus this value. Enter. So 470, 470. Got it, no? This is how you are supposed to interlink. Now it looks correct. See, 470 is coming good. 330 is coming good. Now this value, you know how it has to be done. How you do this value? Again, it will take long time, but anyhow, I'll do it. Okay. So first what we used to do? First you have to take 2.5. So 2500 minus what we do? Yeah, minus we have to do the depth of the footing, 400. Okay. So once you do that, you'll reach to the, once you do that, you'll reach to the, uh, yeah. So once you reach there from the top to the plinth beam, you'll get this. height. Okay, then plus plinth beam is 350, plus floor to floor height is 3300, first floor, second 3300, second floor plus 3300, third floor, minus one cover you are supposed to do. Okay, minus one cover, and then you have to add the lap length plus how many lap length? 3 lap will come. So 3 multiplied by lap. So you can directly consider 50 from here, multiply by diameter. So diameter is 16. Okay, close the bracket. I hope we should get the right answer. Exactly, I got 14710, 14710. Finish. Right, see, that is how it is. So if you practice anything, you can get the answers. I got the answer, same answer I brought. 196. Okay, now I think one value change, no? Yeah, 196. Correct. This is also 196. Fine. Got it, no? This is how you are supposed to interlink. So up to here you can do. After this, you have to prepare a shape like this, right? This shape also I'll teach you, no problem. Now for that, what you do, you have to mention the column size here. So here you select in this way, merge at center. I think not merge at center, sorry. What I need to do is, this is column. How did I do? Yeah, column size 2 I require. Okay, fine. So this one, and this one. This point, right, this one. Okay, and right here. Okay, this you merge now, like this. Okay, merge at center. So column, C1 column you write, C1 column. And what was the size? It was 200. It is actually, okay, 200 is a breadth and 350 is the depth of that. Okay, finish. And this shape you want to draw now, right? This shape you are supposed to draw. How you will draw? Again, come here, come to the insert, go to the illustrations, go to the shapes. Now you take this option. Which one? This option, if you take, it will look good, and draw the shape. Okay, you're drawn now. So once you draw, come to the shape field, make it this color, white color, and then come to the shape outline, weight, and then increase the weight of that. Finish. You got that shape. Okay, once you got that shape, next what you're supposed to, again go to insert, illustration, shape. This time you take circle, and in the circle try to put circle. So this will be your rebar. Okay, one rebar. This is a second rebar. This is a third rebar. This is a fourth rebar. Now if you want to change the color of the rebar, we could have done, select all the 4 rebar by pressing the control button, go to the shape field, give red color. Finish. Fine. Next, what is left out? Again, come to the insert, come to the illustration, come to the shape, take one this thing. Okay, and then you just keep and drag it here. Okay, this thickness you have to increase. Go to the weight, take this weight, and again select this, control C, select this, control C and control V. One more will be added. You keep it here. Okay, enough. So if you do like this, it's understood. Else you can decrease the size of this to make it look good. Select that, go to the shape, shape outline, go to the weight. This weight you make it little less. Now it will look good. No, it feels like it has gone inside this. Okay, done. No? Shape is ready. So once the shape is ready, next what you're supposed to do? You want to find this, no? This is how much? This is 350. This is 200. So you know how to do that. So for that, again you have to write bar description. So here you have to put columns. Okay, here that this thing should come. I'll write here. Okay, ties. I'll write this time. I'll write ties. Ties for C1 column. C1 column. You should write that. Number of member, how much? 1. So here you don't write 1. Whenever you write here, you have to interlink to this. So by default, the moment you write there, it will be interlink here. Okay. Dia you don't have to interlink because dia will be 8 mm usually for this. So write 8 mm. Spacing was 200, right? 200. Fine. Okay. Now we'll find this. So what you'll do, keep your mouse here, hit the enter button, open the bracket. So this is 350, no? 350 minus 40 mm from the left side, minus 40 from the right side, minus one stirrup, that is 8 mm, close the bracket. What we'll get? 262. Okay, you got 262 here also. I brought 262. Select this and bring it to the center and bring it to this. Okay, or bring it the center. Do one more thing. One more thing I'll tell you. See, since we have done this, it is not. If I want to pick it from here, no, it will not come. So what you do? So what you do, no? Select this. Select this for. You have to press the control button. Okay, select this and then select this and select this. Everything you select. Right click Go to the group and say group, done, finish. Now it will act as a one single unit. Now you adjust this. Okay. Now if you adjust it in this way, no, it will come exactly at the center. Now here, again, what you will do, right here, keep here, where you can keep here. So plus, click on this. Same, it should come same, no? Select here, bring at the center, bring at this point. Okay, good, no? Yeah, now again, I think it should come down. Yeah, come to this, bring here. Okay, fine. If it's not coming, no, just drag it in this way. It will look good. Fine. Okay, fine. Now this one, how you'll do? Plus, open bracket. Your this is 200 minus 40 on the top, minus 40 from the bottom, and minus 1 dia of the rebar. Close the bracket. Finish. Answer is ready. 112. But you bring it to the this thing. Okay, where it will go? Okay, it is here only. So in that case, what you can know, you can just pull it like this. You just take it to the top. Now it will look good, no? Yeah. Now same thing. Here, click it, plus, and this one. Finish. So I think it has gone inside. Bring it outside. Finish. Looks good, no? I think, yeah. Now if you want, you just adjust the size of that according to the dimensions. Now everything is ready. Finish. So this, I think you can, enough. Everything enough. Okay. It looks good. If you want, you can make it bold little. Select all four. Make it bold, and you can even change the font of that. Finish, no? Now if you want, increase the size. So it looks good. Yeah, done. Now it's clear, no? Fine. And that's it. Now how we'll find the number of bar? Number of bar will be, you know how to find the number of bar. I already taught you how to find the number of bar. Okay, I'll not do the same thing. Okay, you have understood, no? Number of bar. You have to do that round up. 2500 minus 50 minus bottom dia, shorter and longer. Then plinth beam height plus 3300 plus 3300 plus 3300 minus 1 cover divide by, anyhow, I'll do that. Okay, how to do that? Yeah, plus open bracket. So first your depth of footing was 2500 minus bottom cover minus this dia, both side dia. Huh? Why it has to be? Because from here only your this thing will start. Okay, fine. This much minus will do. And from here onwards, plus 350 is a plinth beam height, 3300 ground floor, 3300 first floor, 3300 next floor. So 3 times minus top cover is 40. Once you do this, then that's it, I guess. Right? Yeah, only this much. So once you do this, what is the answer? Okay, this is the answer. Wait, okay. Say sometime I'll okay, anyhow, that will be the answer only. We have to divide that by spacing, no? Yeah, exactly. So whatever answer you got here, no, this answer, it should be divided by the spacing. So spacing is how much? 200, and close the bracket. Okay, and hit the enter. Okay, it won't work out because one column I have given less. One bracket I have given less. Yeah, 63.2 it's coming. So it is coming in decimal, no? So that is why you have to come here, write round up, round, round up. And since it's a bar, no, you have to add plus 1, bracket open 0 and close the bracket. Okay, again on bracket you have to add. That's it, finish. Okay, should come plus 1, 0. How many open brackets are there? 1, 2. Only 2 open brackets are there. Closing bracket 1, 2, 3. I think 1 we need to take out. Okay, let me check what is the mistake. Okay, see. Okay, round, 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 round up. Okay, still that mistake is there, no problem. See, 2 open bracket, then another open bracket, 3 open bracket we have. So closing bracket 1, 2, 3, and 4. 4 closing brackets we have. That means we need to we'll do one thing. This bracket will stop, and now we'll see. Yeah, exactly 65. It has come. Here it was 64, no? Here it was 64. Why it is 64 here? So h by 200 was the spacing. Okay, plus 1. Plus 1 I didn't add here. Okay. One mistake I did. Because whenever you're taking this thing, no, I should have done plus 1. Now it will be correct. Why plus 1? For a very same reason. It's a lateral ties, no? By doing this, we'll find the spacing. That is why plus 1 we should have done. Exactly. See, 65. Here also I got 65. It's okay. Sometime when you do BBS, slight mistake, you go here and there. No, not an issue. Okay. In one, nothing is going to happen. Yeah. Now cutting length will be this plus this. Sorry, this plus, wait. Cutting length will be this this plus this plus this plus what you do? Exactly. So I told how much it should be 24 into D. So 24 into D. So D is this one. And close the bracket. 940, right? What we got the same thing, no? 940. I did the same thing, 940. So cutting length will be again 940 divided by 1000. Okay, finish. So total cutting length will be obviously this one multiply by 65 multiply by number of bar. Done. 66.94. We got, okay, why that change? 61. We got 61 back then. Here I got 65 number of bar. 66.94 I'm getting, no? Okay, see. Mistake is this one. It is multiplication. I have done addition there. Got it, no? So such mistakes usually happens. So cutting length this, multiply by this, multiply by this. 61.1, 61.1, correct. Okay, fine. And the weight, this is 8 mm bar, so it should come here. So this multiply by 0.395, so 24.14. And here also we got 21. Okay, we'll make it 3 digit if you want. 2 digit is better. Okay, 24.138 and we got here 24.135. Okay, slide that all okay. Okay, don't try to be more precise like sir you got 24.138 here and here. It is all okay. It's a decimal. After the decimal the changes is happening, doesn't matter. Okay, got it, no? Now you understood how it has to be done. Finish. Now last one more tie is there. For that I can go to insert, go to illustrations, go to the shape, take this option. Okay, and place it here. Actually no, I'll tell you one more method. Instead of doing this, you do it in this way. Because actually the lateral ties will be put in this way. I did there. You see the lateral ties, how it is shown. One is here. This is your master ring, which we did now. And the other lateral ties, what we have now, it is actually in this way. In this way. Okay. So what you can do is instead of doing horizontally, you keep it vertically. Instead of doing like this, I made it horizontal. No? You people can make it vertical so that you don't have confusion. Okay. Illustration, go to the shape and go to this option and take it vertical. Okay, like this vertical means. Okay, yeah. And then once it is done, go to the shape outline, weight and this weight. Okay, and color is this one, same color. Okay, color we can go for blue. This one we have taken. Okay, anyhow I'll take this color. Okay, blue. But one thing, this you cannot make it this particular shape like control C and control V. You cannot make 135. You can do, but it will not look so good if you want to do like this. Okay, it will be something like this if you do. If you want to keep it in this way, you can do that. Wait, like this you can keep if you want. It will look good. Else, what you can do is there is one more option. Go to the insert illustration shapes. This option you can see curve arc. So you try to take a arc from here and you have to make a kind of a arc, something like this. This is how I did. Okay, this will not work out here because I can go to the insert illustration shapes, take this one curve. Okay, this also won't work out. So what I can do is simple, go to the illustration, go to the shape, take this only, this one arc, and you try to make a arc like this. So this arc will be like this only. Anyhow, it's okay if this arc comes like this also, it's okay, it's understood. Okay, now we cannot make that exact shape, else we have to take some image and do it. Okay, this is okay. Select that, go to the shape outline, go to the weight, make it dark, and then what you do is you have to rotate it in this way. Got it, no? And then you keep it here. Wait, yeah. Keep it here like this, and this you can drag a bit. Got it? Otherwise you can go the other way also, just because all this one time effort, that's it. So okay, but now the problem is it won't rotate. Yeah, it should be like this now. Okay, see, now it looks good. This is okay. Whereas here there is small problem. We'll do one thing. Okay, and I'll rotate this, and then I'll bring it here. Rotate this. Yeah, now it should look good. Yeah, now it's fine. See, got it now how I did it. And select all the three now. Right click, go to the group and group. Now it's fine. You can take this anywhere. Okay, this is how you're supposed to do. If you want to increase the now you can just drag it like this. Okay, it won't look good. So go back. That font, if you want to go to the shape outline, weight, increase the weight of that. Okay, then same as usual, you can select this also. Now you cannot select this. Okay, select this, Control C, Control V, Control C, Control V. Okay, okay, not possible. Go to insert, illustration shapes, take a circle, and then put this. Okay, then give that color, red color. Same thing, copy and paste it here. Done, no? Fine. Now you write it. What you will write? Plus this will be equal to this one. Okay, finish. So it will come there. Bring it to this part. Bring it to the center. So it won't come, no problem. Just okay. Now again, group everything. This you have to group this, and this overall, and say group and group. Now it will come here. Okay, fine. And then this one, this hook, what? How much it will be? Hook will be how much? Hook was yeah, 13D and 13D. No, fine. So again, right here. Keep your mouse here. 13 into diameter. So diameter is 8 mm. Enter. Finish. So it is 104. No, exactly 104. Click here and bring it to this point. So okay, no problem. It will come. Else you can bring it here, but again then you have to drag this. This also can be done. This also will look good. No problem. We'll take it to the top little. This we can increase like this. Not possible. No? Okay, fine. And same thing you keep here. Plus 104. Enter. This has gone there and select on this. Finish. Understood, no? Yeah. So in this way, we have created the Excel sheet. Now nothing. Just copy the same thing. Like if you want to copy the same thing, Control C and paste it here and say Control V. Ties for C1 column. Okay. This is link, not ties. You can call it as a links. Links for C1 column. Number again, try to connect the same thing. Plus this and this will be same. And then 8 mm. This 8. Try to connect from here. Die also will same. Spacing also obviously it will be same. Most of the cases it will be same. 95 cases it will be same. Few people change it. This also same. Okay. You copy the same thing. Plus this also will be same. Only the cutting length will change now. So for cutting length, I think we'll do that. So cutting length will be plus this, sorry, this one plus this one plus this one. Enter. So 320, 0.32. Total cutting length will be 0.32 plus 65 into 1, correct? And weight of 8 mm will be how much? That's it. This cutting length multiply by this one. So 8.217. I think same thing. Yeah, exactly. 8.216, 20.8, 20.8, 8.217, 320, 65, everything same, no? That's it. Finish. Got it, no? So in this way, I've done everything for you. Okay. And finally, if you want to write, you can write the total weight. I'll simply write here 8.217 plus 24.138. And I think this one is 196. Enter. So it is 228. Same thing we had got here, no? 228.397, 228.433. Got it, no? Now this one, if you try to, minimize and put it in one single line, it will look like this. Okay, that's it. The other part you have to decorate. That's it. This part and you decorate. Okay, like increase the size of this and all those things you do, like I did here, no? In this way, you have to do it. Okay, got it, no? Try to do it. So this is a good Excel sheet where you can make use of this Excel sheet and any BBS can be solved. Okay, but again, I always mention Excel sheet are project specific. One Excel sheet, this same Excel sheet we may not help you tomorrow. Then you have to create your own Excel sheet. That is why I'm teaching you to create the Excel sheet, so that in future, any project you can work on, any Excel sheet you can create on your own. Everything I taught here. Okay, great. So I hope you have enjoyed my lecture up to here. So prepare your Excel sheet, and also in the next lecture, I'll take the other columns and all, and we can practice on that. We'll see you back in the next lecture. Thank you.